for Beginners, Lesson 1. Today we're going to talk about variables. You're going to learn about what they are, how to declare them in Swift code, and furthermore, how to use them. Alright, so let's get started. For the rest of the lessons in this series, we're going to be working inside this app called Xcode. Xcode is the tool that Apple has provided for people to build apps with. And inside Xcode, you're going to be able to create your user interfaces. You're going to be able to write the code. Hello, welcome to Learn Swift Programming for Beginners, Lesson 1. Today we're going to talk about variables. You're going to learn about what they are, how to declare them in Swift code, and furthermore, how to use them. Alright, so let's get started. For the rest of the lessons in this series, we're going to be working inside this app called Xcode. Xcode is the tool that Apple has provided for people to build apps with. And inside Xcode, you're going to be able to create your user interfaces. You're going to be able to write the code to express the logic in your app. You're going to be able to test your app even. So that's why this is where we're going to start in learning Swift. We're going to be writing the Swift code inside the app that you're actually going to use to build apps with in the future. So this is where you're going to get Xcode. Just go to your browser, go to developer.apple.com/Xcode, or you can launch the Mac App Store on your computer and search for Xcode there. If you're on the web page, you can see that there's this big blue download button up top. Now, ideally, you want to make sure you're using the latest version of Xcode, and right now, as of this recording, it's 8. And you can check your version if you go to Xcode. You can see it here in the welcome screen, and you can also go up here to Xcode, about Xcode, and you can see what the version is. If you're a PC user and you're running Windows, there may be some additional work you need to do before you can run Xcode, or you might have to use an alternative solution to build iOS apps. So check in the description below for PC solutions. However, if you are a PC user, don't let that discourage you. For me personally, I lost about 2 to 3 years of learning iOS development simply because I didn't have a Mac and I didn't want to get a Mac. But these days there are alternative solutions. You don't actually have to buy a Mac computer, although I eventually did, and now I haven't looked back. So anyways, now that you have Xcode and after you've installed it, it's a pretty large install. It's a pretty big program. So it might take some time, but after you have it installed and you launch it, you're going to see this welcome screen. You can see here that when you want to create an app for iPhone, iPad, Mac, or whatever, you're going to go to create a new Xcode project, and that's going to start a full out project for you to build an app in. But here we're going to start a new playground because that's going to allow us to type some code quickly. It's going to let us run that code and see the results, and we're not committing to building in a project. It's simply like a sandbox or a playground as it's named. Now, if you don't see this welcome screen, what you can do is just go up to File, New, and hit Playground right there. And that's going to start a new playground for you as well. Or you can just hit this button, Get Started with the Playground. So that's going to launch this dialog for you. And I'm simply going to leave the default name there. Platform should be iOS. And I'm going to save this on my desktop. Okay, so after your playground runs, you'll see up here it's doing a whole bunch of stuff. Launching simulator, getting it ready, and when it's done all that, it's going to say ready. You can already start typing in code, so there you go, it says ready. But when it doesn't say ready and it's doing something, then chances are whatever you're typing here is not going to show up on the right hand side. Okay, we're going to start with a quick tour of this playground window here. So down on the left hand side, I have a bunch of line numbers. Now if you don't have these and you want them, they can be useful at times, especially when I'm teaching and I need to refer to line numbers. You can go to Xcode Preferences and you can go to Text Editing and you can simply enable line numbers there. Now this area right here is where we're going to type our Swift code, and it's already got a bunch of stuff for us right here, which we're going to go through in a second. On the right hand side, you're going to see a quick preview of the results of what you typed there. Now, a lot of people have trouble with getting output to show up on this right hand side based on what they type here. Well, one of the things that you can check is just in this status bar up here, make sure that it says ready. And as you're typing something, let's say I change something like that, you're going to see that it, for a brief second there was a little spinner because it's evaluating your code here. If you want it to show up, just make sure it says ready to process your next command, and you should see that output there. Alternatively, there is a tray down here, which you may not notice because it's hidden at first. You can hit this button to show the debug area, or there's also this little button here to hide the different panels. Okay, but we don't need to see all of that. But this debug panel may be useful when we start to output things here. This is called the console area, where we can use Swift commands to output things. This blue icon here is to execute the code in your playground. So if you can't get things to show up on the right here, try clicking this button to run your playground. Right now it's blue because you can see there's a little drop down arrow there. If you click and hold it, you can see whether you want to switch it to automatically run, and that's going to run the playground whenever you type something, or you can set it to manually run, and you can see now it's grayed out. So if I type in some new code, it's not actually going to change or display what I have on the right hand side here unless I click the play button to run it. So I would recommend to have it set to automatically run. So now that you know the main areas of the playground, let's get into the meat of today's topic, variables. And in fact, what we have here is a variable. In Swift, a variable holds some data. Now this data could be a value, it could be a reference to an object, or it can even point to a function, which are things that we'll get into the future. But for now, we're going to say that variables hold data. Now, as you can see from this example line of code, a variable has a couple of distinct parts. Let's break it down. Variables need to be declared before they can be used. So this var keyword is used to declare a new variable. Following the var keyword, you have the variable name. In this case, it's str. And really, that's it. You've declared your new variable. So it's got the var keyword and it's got the variable name. Now taking a look at the whole line, what we have on the right hand side there, that's some data. We did say that variables hold data, right? And that equal sign in between the variable name and the piece of data, well, that's an assignment operator. So what we're doing in this line of code is we're declaring a variable called str, and then we're assigning that piece of data to that variable. So now jumping back into the playground, let's see the effect of that. I can say something like print, which is a keyword that is going to print something to that console area down below. So if I say print and then in the parentheses I put str, you can see that it's printed that 𝗩𝗶𝗱𝗲sref line down there. On the right hand side, we can see a quick preview of that, and notice that there's a /n here, and that is basically just denoting that there's a new line associated with that print statement, because the next time I print something, it's going to be printed on the next line. So you don't see that here because a new line is just a carriage return or a white space. You can't really see it. But in here in this preview, it's visualized as that /n, which is just a new line. So let's take a look at a couple of different pieces of data that we can store into variables. So I'm going to declare another variable here called a, and I'm going to assign a number into it. So just var1, and I'm going to declare another one called b, which I'm going to also assign 1. And I want to show you that you can perform operations between the variables or on the variables. So for example, I can say print a plus b. And you can see here that the result in the console here is 2. Now notice that when I'm using the variables in an equation or an operation like this, I don't need to use the keyword var because that's only for declaring variables, right? So this little part is declaring the variable, but when you use them afterwards, you just need to refer to them by name. So let's try some other things. Print a minus b, right? Print a times b. Okay, so variables hold data and you can perform operations on variables. Now you can change the data that the variable is holding. So I can say something like a equals 2 now, right? In fact, actually, let's not do it down here. Let's do it here. After we've assigned 1 into a, let's say a equals 2. And as a result, you can see all of these operations have changed because a is now 2. So a plus b is 3, a minus b is 1, and so on, because a is now 2. Now when you assign something into a different piece of data, it replaces what it was holding on to before. So a is no longer 1. It is now 2. But notice how when we assign a new piece of data into a, we don't have to write var again. That would cause an error because we've already declared that variable up here, and memory in the system has been allocated to it, and so we don't need to redeclare it. All we need to do is assign new data into a, like that. Now if you're playing around in the playground yourself, you may notice something like, what if you try to assign something into str, like 1? Well, you're going to get an error, and that's because of something called data types, which we're going to learn about in the next lesson. But for now, just know that for str, because we've assigned some text into it up there, if we want to reassign some data into it, again, it has to be text as well. So that would be valid. Furthermore, you can also assign a variable as another variable. So I can say a equals b down here. And in that case, a would now equal 1 again. Well, it was 1 to begin with. So let's say I did that. So if a was 2, and then I said a equals b, then now they would both be 1. Now before we move on, a quick note on naming variables. Here we have a variable str, and I've named some variables a and b. So normally you wouldn't name variables like a and b because they're not descriptive of the data that they hold. So if you're going to be using variables just like this in an operation, wouldn't it be easier if you knew what a represented and what b represented? Well, you can declare your variables using any sorts of names that you would want, but you can't put some special characters and you can't put spaces in your variable name. However, the common practice is to use a form of camel case where the first letter is lowercase. So let me show you what I mean. So I can say var, and if I want to describe my variable, if it represents, let's say, the number of apples that I have, I would say something like my number of apples, like that. And you can see that each new letter of each word is capitalized except the first one. Now you don't want to get too crazy with the length of the variable name as well, and you don't want to go too short, so short that it doesn't actually mean anything. So there's no right or wrong answer or hard limits. It's based on, you know, your own preference, and it's more important if you're working in a team with other people that you agree on a certain coding style, because you're both going to be working on the same code. Okay, so one more thing I want to talk about are constants. So they are like variables, except that once you assign something to them, you can't reassign data into them. So that's really the only difference. That, and also how they're declared. So with variables, you use the keyword var, but with constants, you use the keyword let. So I can say let c equals 10. And then down here, if I try to reassign something into c like that, Xcode is not going to like that, and it's going to throw an error, and it's going to tell you with this red dot down here, and if you click it, it's going to say cannot assign value to c because it's a let constant. Now it gives you this little bubble here which you can click, and smartly it's going to change let to var because it senses that you want to reassign data into it. So you might ask, why would I ever want to use a constant if it's more limited in its functionality? Right? If I declare everything as variables, then I have all the flexibility I'd want. Well, there are a couple of reasons why you'd want to use constants when it makes sense. For one thing, it helps the computer work a little more efficiently because it knows exactly what that constant will be, and that's not going to change. But more importantly, it's that for you as a coder, you know that that constant isn't going to change. Because when you're building your app, you're going to have a lot of variables, and when you have some sort of issue in your app and you don't know why it's happening, and you're tracking down your code, you're tracing it line by line, and you're trying to see if maybe at some point you've accidentally assigned something to a variable and that's throwing off all your calculations or all of your logic, it's going to be a nightmare to try to solve and untangle. So if something it isn't going to change, you can assign it to a constant, and then when you're looking through your code, you can be sure that the issue doesn't lie with that constant because it can't change. Okay, so that's it for this lesson on variables. I hope you're practicing on your own computer with Xcode, and check below this video for a link to the cheat sheet and the notes. Hello, welcome to Learn Swift for Beginners, Lesson 2. In this lesson, we're going to talk about data types. Did you know in the previous lesson that you were already working with different data types? Well, let me point it out to you. Let me open up the playground that we were working with in the previous lesson. Do you remember how we were trying to reassign data into the variable str? And I was assigning something like a number into str. And I told you that you couldn't do that. In fact, Xcode tells you that you can't do that right here. So if we take this little console area and we scroll the scroll bar all the way up to the top, the error message actually tells you what's going on. Cannot assign value of type int to type string. Well, what's an int and what's a string? Well, those are two examples of data types. Just as the name implies, a data type is a classification or a type of data. For example, a string is a data type that describes pieces of text. An int, short for integer, is a data type for whole numbers, negative or positive. However, there are many more data types than just these two. Other types of data that you'll commonly be working with are float for floating point numbers or decimal numbers, and then there's double for decimal numbers where the decimal portion may be very large, and then there's Boolean, which represents true or false, or in other words, yes or no. These are some of the more common data types that you'll be using. And the reason why there are different types of data is because the system stores different types of data differently. And so when we go back to the playground and we take a look at this variable that we declared here, str, and it stores a string, the system has allocated this variable to store this piece of text, or string in other words. And when you try to assign an int into that same variable, it doesn't allow you to do that because strings and ints are stored differently. Now you might be wondering what differentiates a variable that stores a string, like this str variable, versus a variable that stores a number or an int, like this variable a. Well, when you declare a variable, you learned in the previous lesson that you use the keyword var and then the name of the variable. Well, optionally, you can also put beside the variable name colon followed by the data type. And if you declare your variable this way, you're basically telling the system that this variable can only store this type of data. And if you omit that part and you just simply declare your variable with var and then the variable name, then what it's going to do is as soon as you assign a piece of data into that variable, it's going to take a look at what type of data that is and assumes that that variable stores that data type. So now going back into the playground here, it's as if we declared this str variable like this, right? And these ones are like this. Now, for instance, if I declared this str variable like this, then this line would be an error because I'm trying to assign a string into a variable that is of type int. So it's not going to like that. Now, let's change this back to a string for a second and go back to this line where there's an error. Now you understand why this line is in red, because we can't assign an int into a string variable. Well, there are ways to convert data from type to type. In some cases, it makes sense, like 29 here, this int can be represented as a piece of text, simply like that, right? But conversely, this hello playground line right here, I can't convert that to an integer because it doesn't make sense that this message could be represented by a number. So for example, just as a little preview here, if I wanted to convert this number or this integer into a string, I would create a new string and pass in the number like that. Now I'm not going to go into detail about why this works or what this line is, because then you're going to have to learn about classes and initializers and stuff like that. But for now, in this lesson, I want you to understand that there are different data types, why there are different data types, and how that comes into effect when you're declaring your variables and working with your variables and your data. Now, before we end this lesson off, let me just show you a couple of examples of the other data types we talked about. So a float could be something like that. A double usually also looks like this, and you're not going to have a really large decimal point unless it's like a result of a calculation that you're doing. And let me show you a Boolean, which is represented as bool. So you can set this to the keyword true or false, which is going to come in handy for the next lesson that we're going to do on if statements. Oh, and there is a mistake here because I'm redeclaring C. Did you see that? In the previous lesson, we talked about how you can't redeclare a variable. See, we declared var C up here, but I forgot that we had tried to declare a constant with the same name down here. So this is going to have to be F. I'll show you some other types of data conversions here. So I can say, let's print out, let's change C, which is a float, into an int. And what's going to happen is that it just drops the decimal portion of that. So if you did print, let's convert D, which is a double, into an integer, you can see here that it just chops off the 0.9 and you get 13. Now there is a rounding function which we can try out right now, like that, and then inside the parentheses you can put D, which is our double, 13.9, and what you're going to get as soon as it finishes processing is 14, like that. But notice that the result is also a decimal number. See, it has a 0.0 there. So what you can do is wrap the result of that rounding inside a pair of brackets like this, inside an int. And then you'll get 14 without the decimal. Okay, so that does it for data types. Hello, welcome to Learn Swift for Beginners, Lesson 3. In this lesson, you're going to learn how to express some simple decision making in your Swift code using if statements. Alright, let's get started. So for this one, we're going to start a brand new playground. Alright, so we've done this before. Let's just call this one the if playground, and I'm going to store this on my desktop. Okay, so we're talking about if statements today. And this is really exciting because it lets us finally start to make decisions through code and express some sort of logic. So for example, if I have, let's declare a constant here. So let a equals 10, for example. And I wanted to print this statement only if a is less than, let's say, 11, which it is right here. But okay, actually that is not right. Let's say 4. And this gives us a reason to use the if statement, right? Okay, so print only if a is less than 4, but a is 10, right? So we shouldn't be outputting this. So what we can use here is an if statement, and what it allows us to do is only execute some code if a certain condition is true. So in this case, we want to print this only if a is less than 4. So we can write an if statement to check if that's true or not before we print that statement. So let me show you what that syntax looks like. And if you're not familiar with programming terms, syntax is simply like the grammatical structure of the language. So it's basically the keywords to use and how we go about declaring an if statement or writing an if statement. So it all starts with the if keyword. Following the if keyword, we have the condition in which we want to check. And following the condition, we have a set of curly brackets. Now inside the curly brackets, that's where we put the code that we want to run if that condition is true. So that's your very basic if statement. Now going back to our playground, let's write it out and print this only if a is less than 4. So we can do something like that, if a, and then we can use this operator less than 4, and remember we need to surround the piece of code that we want to execute if the condition is true using a pair of curly brackets like that. So you can put the curly bracket on the same line or you can put it on a second line, it doesn't matter. But what you usually want to do is indent the code that is inside it, just so it's easier to read. I usually like to put this curly bracket in the same line like that. Okay, so now you can see that in the console there's nothing printed, and also to the right here it doesn't give you a preview because this condition is false. A is not less than 4 because a is 10. Now what if we changed a to 1 and let the playground process? Okay, now it prints this statement and it previews this statement. See, it's printed down here. So that's your very basic if statement. Now there are other cool things that you can do with an if statement. There is an else if clause. So for example, using the else if clause, you can check a second condition if the first condition evaluates to false. And the syntax for that looks like that. So you have your if condition and then you have your curly brackets, and then you use the keywords else if, and then you check another condition and you have another set of curly brackets. So if you write it this way, you're basically checking condition number 1. You know, is that true? If it's false, now you're checking condition 2. And if that actually evaluates to true, then you're running the code inside that else if block. Now keep in mind that it kind of goes from top down, and if the first condition is actually true, then it's going to run that piece of code inside the first set of curly brackets, and it's just going to ignore your else if statement. So let's take a look at that inside the playground. So here I'm going to put else if a is less than let's say 8. Then now I'm going to print only if a is less than 8. So now I'm going to change, oops, not this, I'm going to change a back to 10 here, and you can see nothing gets printed because first it checks this condition. If it's false, which it is, then it's going to check this condition and it's also false, so nothing gets printed. Now what if I changed a to 7? If I changed a to 7, you can see that it prints the second statement because first it checks this condition, that's false, so now it checks this condition, and that actually turned out to be true, so it's going to run this line of code here. However, if a is 1, then it checks this first one and then it prints this one, and then it totally ignores all of the other else if conditions. Now I said all of the other else if conditions, right? I say that because you can have as many else if conditions as you want. So you can say if a is less than 10, and then you can continue adding as many conditions as you want, but keep in mind that it checks from top to bottom, and as soon as it finds a condition that is true, it's going to run that piece of code and ignore all of the other conditions. Now finally, there is a clause that you can run if all of the conditions are true, kind of like as a failsafe or as a last resort, and that is the else keyword. So the way you write this is using the else keyword. It's not else if, it's just simply else, and there's no condition attached, because if all of the conditions above it are false, then it's going to run the code inside of this else statement here. So going back to the playground, let me show you what that looks like. Else print nothing was true. And now let me change a back to 10 here. So you can see that it prints nothing was true because it's checking this statement, it's false, this statement is false, and conditions. And this condition is also false because a is not less than 10, a is actually 10. So this would actually evaluate to false. And finally, it just gets to this else clause and it's going to print what's in here. Okay, so let me show you a couple of other things that you can do with else statements, and let's change these print statements to something that is a lot more recognizable or easy to read. Let's do that. Branch 1, branch 2, and here, branch 3. Okay, so first of all, let me show you how to do less than or equal to. Now you see it prints branch 3. So that's how you do less than or equal to, and likewise you can do greater than or equal to. And you can see here it still prints branch 3. Now what if you wanted to check if it was exactly 10? You wouldn't do that because remember, this equal sign is an assignment operator. So what you need to do to compare if a is equal to 10, you use the double equal sign like that. You can see here it prints branch 3. Okay, so why don't we introduce another constant up here? Let's say b, and let's have that equal to 4. I want to show you that your conditions for your if statements and your different branches can get pretty complicated, and you can involve multiple pieces of data in your condition. So you can go if a is less than 4, if you want to check b as well, and you want to say, and b is less than 4, that's how you would do it. You would use this double ampersand sign, and now you're checking two conditions. You're checking is a less than 4 and b less than 4, and only if both of those are true are you going to get this branch here. So let's try that out. So if I set b to 1 and a to 1, then both of these conditions here are true. So it's going to print branch 1. However, if I set b to 10, right, it's going to just, see, it hits this branch 2 now because a is 1, which is less than 8, and it didn't print branch 1 because this was false, right? Even though a is 1 and this part is true, we have to have this part to be true as well because we're saying is a less than 4 and b less than 4, and b is 10 right now. However, you can also do or. So you can say is a less than 4 or b less than 4, and in this case either condition can be true, and that would cause it to go into this branch. So you can see now it is in branch 1. All right, so let's say a is 10 and b is 1. So a is not less than 4, but b is, right? Because you're using this or statement. You're saying is a less than 4 or b less than 4, and if that's true, then we're coming into here. Now furthermore, if you wanted to involve, let's do a c, you can combine multiple conditions like this. You can put this into a pair of parentheses like this, and you can say and c is equal to 3. So you can see now that you're saying, okay, is a less than 4 or b is less than 4, and also is c equal to 3, then come into branch 1. Now these brackets matter a lot because what you're doing is you're saying that this has to be true and this has to be true. But for example, if I just shift the brackets a little bit and I say something like this, then that changes the meaning completely, because now I'm saying is a less than 4 or is this part true, right? So where your brackets are matter a lot, and it changes the meaning of what you're checking. Did you get that? In this case, I am checking, is this true or is this true? But the other way around, I'm checking, is this true and is this true? Right? So the brackets matter. Finally, let me show you another operator that we have here. So here we're checking, is C equal to 3? Well, what if we want to ask, is C anything but 3, or is C not equal to 3? If we only care about the case where C is not 3, we can say something like this, not equals to 3. And this is going to say, is C not equal to 3? So you can see here that C is 3, so that's why it completely skips this branch, and it ends up being A is equal to 10, and it prints branch 3. Now you can use this not operator, this exclamation mark here, on other things as well. So for example, here I'm asking, is A equal to 10? Right? And I am, it's coming in here because A actually is 10, so it's printing branch 3. But if I surround this like that, let me put something else in here. Is A equal to 10 and B equals to 1, right? That is true, so that's why I'm still getting branch 3. But if I put an exclamation mark here, like that, it basically flips it around. So this evaluates to true, right? A is a 10. This evaluates to true. This whole condition evaluates to true, right? A is A equal to 10 and B is equals to 1. And then, so we get true, but then we're adding this guy here. It flips that true to a false. So that's why this whole condition equates to false. Okay, so that does it for if statements. I hope you're trying this out on your own computer in the playground, because trust me, it's pointless to try to memorize all of the keywords and the syntax for the Swift. It's much better if you only spend 30 minutes, instead of trying to memorize things, spend 30 minutes in the playground, just punching in different numbers like that, playing around with the different conditions and expressions, and printing out a bunch of stuff in the console. In 30 minutes, you'll remember a lot more just by doing that than trying to memorize, how to declare a variable or how to declare an if statement. So, if you can, get a Mac, get Xcode, open a playground, and then type this code out for yourself and play around with it. It's going to do wonders. So thanks again for watching, and if you like this series so far, please give the video a thumbs up, please subscribe, it really helps. Hello, welcome to the Learn Swift for Beginners series, Lesson 4. In this lesson, you're going to learn about switch statements, and like the if statement, it allows you to make decisions with your code. Alright, so let's get started. Let's start by creating a new playground for this example. And I'm going to start labeling these after the lessons here. And I should have done this sooner, but I want to point out that Apple does have a Swift programming language guide. And in this guide, it goes through all of the syntax and the structure and the different concepts of the Swift programming language. It's what we're doing in these videos and more, in fact. So if you want something to read, you can go ahead and visit this website here. I'll have the link below the video. But one thing to note is that it may be a little bit complicated for the absolute beginner who doesn't have programming background, but give it a try. And it's a great complement to watch with this Learn Swift series that you're watching. In fact, as we're going through the different concepts in these videos, I'll point out in the guide where they are. So for example, we're looking at the switch statement today, and that resides under control flow, and you can see here what the basic syntax is for this switch statement. Okay, so let's jump back into our playground and we can do an example of a switch statement. So in here, I'm going to basically do the same example or similar example as the one in the guide, and I'm going to introduce a new data type called character. And it's basically like a string, except that it's just a single character like that. And with an if statement, we can do something like this. If some character is, equals a, for example, okay, like we have right here, print is an a. And this is going to be true, and it's going to print this out. And then we're going to have else if, and we're going to maybe check another condition if we wanted to, respond to different cases depending on what letter this variable is, right? But you can use a switch statement, and it looks like this. So we start with the switch keyword, then you have the value which you're considering. In our case, that value is in the variable some character. So that's what we would put in there. And then you open up a pair of curly brackets. Inside these curly brackets, you have different case labels. So you would have case, if you wanted to consider the case where the value is an A, you would have case A, and then you have colon, and you would have something to do if it were that case. Perhaps this would be easier to visualize if we take a look at the playground. So let's jump back to the playground here. So let me say switch statement, right, on the value that we're considering. So that's some character. And you open up a pair of curly brackets like that, and then you have your case labels. So I have case, if it's an A, and if I want to do something for this case, right, then you have a colon, and in here you would print, let's say, is an A, like that. And if there's another case, right, I would have case B, for example, and I would say is a B. And lastly, if none of those cases are true, I would have a default case like that. And I would say print some fallback. So in this switch statement, this case was true, right? So it printed out this statement and it doesn't do the rest. And you can have more lines of code in here than just the print statement. In all of our examples, I just wanted to show that it's coming into here, this branch, but you could execute more code in here. Now the case where, character is a B, then we would come into here and jump into here. Now if it's none of those cases, we would have default, and it would print that. And of course, you can have a whole bunch of different case labels. It just doesn't have to be the two that we have here. And the benefit of using a switch statement is that rather than using an if statement and having all of these else if clauses, reading this is much more clean, and it's a lot easier to read as well. So what if you wanted, let's say, two different cases to run the same piece of code or the same block of code? So for example, if I change this to say is B or a C, is a B or C, I could do something like this with this case label here. I can do that, comma, and then I can put this other case there. So this saves me from having to have another case C and then the same code. I can put a comma here, put the other case here, and have either one of these cases use the same block of code. So now you can see that it comes into this case here, it prints is a B or a C instead of coming into default. So why would you want to use a switch statement over an if statement? Well, if there are a lot of different conditions that you want to check on a certain value, rather than using an if statement with a whole ton of else ifs, you can use this switch statement, which is easier to read and easier to understand. You're probably going to use the if statement more than the switch statement, but it's still a handy tool to have in your arsenal. So I highly recommend that you try this out in your playground. So that's it for switch statements. This is a short one. I hope you enjoyed it. Please help this channel grow by subscribing and hitting that thumbs up button below the video. Hello, welcome to Learn Swift for Beginners, Lesson 5. In today's lesson, we're going to talk about loops. When you're writing your app, there's going to be many times you're going to find yourself needing to repeat pieces of code. For instance, let's say you're showing 5 things in your app, and you need to turn each of them red. So a loop is going to allow you to just write that single line of code to turn something red, and you can repeat it 5 times for each of those 5 objects. And that's going to save you from having to write out that code 5 times. So that's a very simplified example, but trust me, you're going to use them a lot. So let's take a look at how to use them. So there are 3 types of loops we're going to cover today. We're going to start with the for-in loop, as you can see in the Swift programming guide here. So let's go ahead and start a new playground in our Xcode, and I'm just going to call this the loop playground and save it on my desktop. Now a for-in loop allows you to repeat a piece of code a certain specified number of times. If you have a list of data, otherwise known as an array, which you're going to learn about in an upcoming lesson, you can also use a for-in loop to go through each of those pieces of data in that array and execute some sort of code on it. So this is perfect for the example we mentioned in the intro about having 5 objects or 5 items on the screen, and you need to turn each of them red, for example. So let's start with learning how to use a for-in loop to repeat a piece of code for a specified number of times. And when you guys learn about arrays, I'll show you how to use a for-in loop to go through each piece of data in that array. So as you can see, true to its name, the keywords to use here are for and in. So you start with the keyword for, and next you have a variable name. Now you don't have to declare this variable using the var keyword like you've learned in the previous lessons. You can simply have a name for this variable, because you're only going to refer to this variable within the for-in loop. This variable that you specify here is going to keep track of which iteration of the loop is currently running. Next up, you have the keyword in, and then you have the lower range followed by ... and then the upper range. And that last part there after the in keyword is the range which your for loop is going to run in. And it's inclusive of those numbers. So for example, if you have 1.5, it's actually going to run 5 times. And then after that, you open a set of curly brackets. And inside the set of curly brackets, that's where you're going to put the code that you want to repeat for that number of times. So let's jump back to the playground and let's do a quick demo on that for-in loop. So I have the for keyword here, and for my variable, I can specify something like index, and then I would put in, and let's use that same example, 1 to 5. And then I open up a set of curly brackets, and then here I'm simply going to print hello. And we're going to see this in the console down here. It is printed it 5 times. Now, part of the reason why you specify a variable name here called index is because you want to use that number or this variable inside your for loop here. So for example, I can do something like this, where I can say print index, and you're going to see that index changes from 1, 2, 3, 4, 5, depending on which iteration of the loop it is. It keeps track of basically where we're at in this range right here as we're looping through it. But again, what we've specified here as a counter is only available inside this scope here in between these curly brackets. I can't specify, printing index out here. It's not going to recognize it. Okay, so we can't do that. And furthermore, if you don't need to use index inside your for loop, you can very simply place an underscore there. So this is perfect for the example that we had initially, where we're just printing hello 5 times. We don't really need a counter of any sort, or we don't need to refer to index. We don't care which iteration it's currently at. One thing I want to mention, which is confusing often for beginners, is this idea of scope here. For example, if I wanted to sum up the numbers from 1 to 5, and I wanted to print out the result after the for loop, let's say I declare a variable up here and I call it sum, and I equate it to 0, and then I say something like sum plus equals, and actually let's add this index variable back here, and I go like this. Now you haven't seen this plus equals sign yet, but this operator basically equates to something like this. It takes sum and it adds the index. So this is equivalent to writing this. It's just kind of like a short form. Okay, so first of all, if I declare this variable called sum inside my for loop, inside these curly brackets, well, this variable is only available within that scope, within these two curly brackets. I can't go out here outside of the for loop after it's run 5 times and print out the result of sum. See, you can see that it can't find this variable even though I've declared it in here. Okay, so why don't we move this print statement into the for loop? What would you expect to happen in this case? Well, we get 1, 2, 3, 4, 5 again. And why is it that this sum isn't increasing? Why isn't it continually adding index to it? And why aren't I getting the sum of the numbers from 1 to 5 by the last iteration of the loop? Well, what's happening is that in the first iteration of the loop, we're declaring sum equals to 0, and then we're adding index to sum, which is 1, and then we're printing sum. So that's why we get 1 down here. In the second iteration of the loop, what we're doing is we're declaring sum again, we're setting it to 0, and we are adding, this time the index is 2, and we're adding 2 to 0, right? And then it's going to print 2. So that's why you can see the output 2 right there. Well, right now you might point out to me, hey Chris, I thought you said that you can't redeclare the same variable. In the first iteration of the loop, we're declaring var sum, right? And then in the second iteration of the loop, we're redeclaring var sum. That's illegal. That's not allowed. In fact, you might say that, if I declare var string again up here, it's going to throw an error, right? We can't redeclare the same variable because we've declared this guy up here. We can't redeclare it using the var again. And I would say that's true, except that in each iteration of the loop, it's almost as if it doesn't remember what happened in the previous iteration. There's no memory or recollection of the previous iteration. So each iteration is kind of like a clean slate, and it's going to execute this code right here. So just to say that again, you're right if you're saying that I can't redeclare sum, right? Because if I tried to do that right here, Xcode would throw an error. However, inside of a loop, in this scope right here, each iteration of the loop is like a clean slate, okay? Now, if I wanted to actually find out the sum of the numbers from 1 to 5, what I would actually do is I would move this declaration up here outside of the loop. And then what I would do this way, I could move this print statement outside of the loop. And what this for in loop will do is simply loop from 1 to 5 each time, adding index to the sum. And now I'm actually keeping track of the sum. So you can see that after 5 iterations of the loop, adding the numbers from 1 to 5 into sum, which started out as 0, the result is 15 down here. And that's from this print statement. Okay, so I'm going to stop the lesson there. While the syntax for the for in loop is actually pretty simple, and the concept of repeating a piece of code for a certain number of times is pretty simple, I want to give you some breathing room to digest what we talked about in regards to the variable scope. So I would recommend that you try declaring and creating this loop on your own computer. Try declaring the variables inside the loop and outside the loop and see where you can access them and use them and where you cannot. It's really going to help and aid you in your learning. Hello, welcome to Learn Swift for Beginners Lesson 6. In this video, I'd like to introduce you to two more types of loops, and that is the while loop and the repeat while loop. And these two loops lets you execute some code until some condition is met. So that's different from the for and loop where it repeated a certain number of times. Okay, let's do it. For this lesson, we're going to create a brand new playground, and I'm just going to call this the loop 2 playground. Okay, so let's cover the while loop first. Take a look at this slide and let's go through how to declare a while loop. So the keyword here is while. Followed by that, you have some sort of condition, and it's very similar to an if statement. So the while loop is going to repeat that chunk of code as long as the condition is true. But as soon as that condition becomes false, it's not going to repeat the code anymore. After your condition, you have a set of curly brackets, and inside of the curly brackets, that's where you have the code that you want to repeat. So let's do a quick example back in our playground. So I'm just going to declare a variable here. I'm going to call this, let's say counter, and I am going to set this counter to 10. And then I would like to print hello. Let's use 5 instead, so it doesn't print that many times. And I would like to print hello as long as the counter is above 0, let's say. So I would say something like while counter is greater than 0, I would do this print right here. However, this is going to keep repeating, as you can see, because counter is always 5. So inside my while loop, I'm going to computer is dying. Okay. As you can see, it eventually overflows and crashes. Okay, so what I'm doing here is I am decrementing counter by 1 for each iteration of the loop. So as you saw, when I didn't have this line of code, it just kept printing hello many times because this condition, would always be false. There was nothing changing the counter variable from 5 to 0. So I'm just going to warn you about that. If you're going to try this on your own computer, if you have a slower computer, it might take a lot longer for you to get out of that out of that loop. So you can write this statement first. Make sure you have a statement that is decrementing your counter. So again, this minus equals is the equivalent of writing something like this: counter equals counter minus 1. So you're just taking whatever value counter is, you're minusing 1, and you're setting that as the new value for counter. As you can see here, it's what you would expect, right? You get hello 5 times. Now, let me point something out to you right here. What if counter was, let's say, -5? You can see here that nothing gets printed out because this loop is going to see if this condition is false or true before executing the code, right? So it evaluates the condition and then it decides whether or not it should run this and repeat it. Now the second type of loop, the repeat while loop, is very similar to the while loop except that it checks the condition after looping once. So it checks the condition down here. Let's take a look at the syntax. So you start with the keyword repeat, and then you have a set of curly brackets, and inside the set of curly brackets, you place the code you want to loop or repeat. And then after the ending curly bracket, you have a while keyword, and then you have the condition. So the syntax of this repeat while loop is very intuitive, actually. It's basically saying repeat this piece of code while this condition is true. Okay, so let's go back to the playground and let's do an example here. So I am going to use the same example. Okay, let's print hello here. And we're going to have the same thing, counter equals counter -1. And we're going to say repeat this chunk of code while counter is greater than 0. So as you can see, it's pretty much the same loop, or same condition rather, right? While counter is greater than 0. And that's the same thing I have up here for this while loop. And let's just print something else here so we can differentiate it. And you can see the repeat while loop actually prints it out once, and then it checks the condition and it realizes, oh, I shouldn't repeat this chunk of code because this is false, right? Whereas this while loop, it checks the condition first and it realizes this condition is not true and it won't print at all. So that's the main difference between the two types of loops. Both types of loops will repeat a chunk of code until a certain condition is false, except that the while loop checks first and the repeat while loop checks the condition after repeating once. Hello, welcome to Learn Swift for Beginners Lesson 7. In this lesson, you're going to learn about functions, how to use them, what they are, and this is a critical part of the Swift programming language if you want to build apps with it. So let's get started. So here I've got a brand new Xcode playground where we're going to take a look at what functions are and how to use them, how to define one, how to call one. If you don't know how to start a new playground, just go back to lesson 1 of this Learn Swift series. Okay, let's start with what a function is. At its very core, a function simply allows you to take a chunk of code, give it a function name, and then whenever you call that function name, it's going to execute that chunk of code. Now that may seem simple, but over the course of the next couple of videos, you're going to see just how complex and powerful functions can be. Functions are really useful because it allows us to break down and group our code into smaller chunks. And we can organize them so that each function or each chunk of code has a specific task. And when you want to do that specific task, then you just call that function. So let's see how a function is defined in Swift code, and then we'll jump into some examples in our playground. So here we have the syntax for our basic definition of a function. Now it can get more complex than this because there are a lot more features of functions that we can use, but we're going to explore those in the next couple of videos. For this example, here is your kind of basic definition of a function. You start with the func keyword, that's func, followed by the function name. Now this function name is what you're going to use to call the function. Now right after the function name, you have two parentheses or two rounded brackets. In this basic definition, there is nothing in between these two brackets, no spaces, nothing. In the next two videos, you're going to see what those brackets are used for, but for now, those brackets are just there as part of the definition, there's nothing in between them. And then you're going to have a set of curly brackets. And as you would expect, in between the curly brackets, you would put the code for the function. So whenever you call the function name, that code in between those curly brackets, that code is going to be executed. All right, let's jump into the playground and do some examples. I'm going to declare a function that is going to add two numbers together, and it's going to print the result to the console. So I'm going to start by using the func keyword to declare a function. And now I have to have a function name. So I'm going to say add two numbers. That's my function name. And you'll notice that I'm using the same camel case as I do for declaring variables, where I start with a lowercase letter of the first word and the following words uses a capital letter. Then I have my two rounded brackets like that, followed by a set of curly brackets like that. And sometimes when you type in this first curly bracket or the opening bracket and then you press enter, Xcode will automatically add this ending curly bracket for you. Okay, so in between the two curly brackets, I am going to say let A equals 1, let B equals 2, and I am going to, let's see equals a plus b. Okay, and then finally we're going to print the result of c. So you can see here that nothing actually happens because this function hasn't been called. This code is sitting here. If we had written this code instead of putting it into a function, so let me just delete this for now, like that. And this is what we've been doing so far before we learned about functions. We would just declare these constants here and then print c, and you would see all of this stuff in the output. Now I'm just going to undo those two deletions. So to wrap this code inside of a function now, you can see nothing gets output until I actually call the function to execute this code right here. So how do we call a function? So in order to call a function, you just have to write the function name followed by the two rounded brackets. Now, because we don't have anything inside these two rounded brackets, that's all we have to do. But as you're going to learn in a couple of videos later, if we have something in between these brackets, calling the function would require a little more work. But for this basic function, we can invoke that function simply by writing its name. So add two numbers, as you can see here, autocomplete even suggests it. So all I have to do is highlight that line, press enter, and what happens now? We get 3 output into our console because by calling that function, it just ran the code down here. And I can call this again as many times as I'd like and anywhere I'd like. One benefit is that if you need to execute a chunk of code several times, this is a big savings. Rather than writing this code out multiple times, I just put it inside a function, give it a name, and now I can invoke that piece of code whenever I call this function name like this. So it helps you reuse code, especially if that chunk of code is going to be used multiple times in your app. You don't want to write out the same chunk of code multiple times in and around your app because it makes it really hard to debug. For example, if you've got an issue with this chunk of code, and imagine if you had it repeated several times in your app, in order to fix it, you'd have to fix it in every single one of those places. But if I have this chunk of code inside this function, I would only have to troubleshoot and debug this piece of code once here. And as soon as I change this, let's say I change this A to a 2, and let's say that fixed my code. And you can see here, wherever I call add two numbers, the code is updated. So I only need to update and change the code in one place. Whereas if I wrote this chunk of code out in multiple places in my app, I would have to change it in all of those places. Another benefit I mentioned is that it lets you group this chunk of code that performs a specific task into a function that describes what that chunk of code does. So it helps you organize your code. So there is one more thing I want to mention about functions, and that is about scope. So same thing we learned about inside of loops in terms of defining variables applies here as well. So let me give you an example of what I'm saying. So let's say I get rid of those two function calls and we simply have this function here. We have these 3 constants. C is obviously 4, right? And inside this function, I'm printing C. So outside of my function, let's say I want to print C. Well, that is actually going to throw an error. That doesn't work. Why? Because the constants and variables that you declare inside a function can only be used in the function, in between these 2 curly brackets. And likewise, if I declared another function really quickly, so inside this function, I also cannot access the constants that I declared here. So if I declared a constant like that, d equals 1, I can't say, let e equals c minus d or something like that. Inside this function, it's not going to recognize what c is right here. So let's get rid of this first. Okay, so there you can see the error. It doesn't know what c is because c is defined inside add two numbers. And so it only recognizes c within this scope, a, b, and c in fact. So inside here, inside this function, I'm free to declare a again because it only applies within these brackets like that. So I can have a minus d. And let's end off by printing e. Okay, so the main takeaways for this lesson right here. You've learned about what functions are and why they're beneficial. You've learned how to define a simple function. You've learned how to call that function so you can execute the code inside of that function. And furthermore, you learned about the scope inside of a function. And just to remind you about that, it's that whatever you declare inside of the curly brackets of a function is only recognized and can be used inside of those curly brackets. In the next video, we're going to build upon what we learned here in this lesson, and you're going to learn how to make functions even more powerful. So thanks for watching. If you liked the video, please give it a thumbs up. It helps this video get seen by more people, and subscribe for more. Hello, welcome to Learn Swift for Beginners, Lesson 8. In the previous lesson, you learned about functions, how to declare them, and how to call them. In this lesson, you're going to learn how to use them in an even more powerful way by having your functions accept data and also return data to you when you call them. All right, let's see how that's done. So here I have a fresh playground. If you forget how to open up a new playground, just go back to lesson 1 of this series and you can see how. Now there's one thing I want to mention before we move on that I forgot to mention in the previous video, and that is that sometimes I may accidentally say method. And when I say method, I actually mean function. Now I noticed that a lot of other Swift teachers also do this. And the reason for this is because for many Swift educators like myself, Swift isn't our first programming language. And in many of the programming languages out there, there is some concept of a function. And sometimes they're called functions, sometimes they're called methods, and sometimes even other things. So a lot of the educators out there, when they're teaching, sometimes they're going to slip up and they're going to say method instead. So I just want to put it out there. If you hear me say method, just know that sometimes I use function and method interchangeably. Okay, so we're going to start by just redeclaring that function that we had in the previous lesson, and I want to redeclare it just for extra practice for you guys. So I think it was something like add two numbers like this, and it was let a equals 1, let b equals 1, and let c equals a plus b, and then we're going to print c just like that. Now in the previous lesson, I mentioned that functions are great for kind of organizing your little bits of code into pieces of code that perform one task. So in this case, this function would add the two numbers together and then it would print out that sum in the console. But what if I wanted the function to just add the two numbers but don't print it out? I just want the result. So in fact, functions have something called a return value. And it's exactly how it sounds. When you execute the function, it returns a value to you. So let's take a look at what the syntax is for specifying that a function returns a value. So everything remains the same as our basic function definition, but after the two rounded brackets, you have an arrow. That arrow is just comprised of a hyphen and a greater than sign. And followed by that, you have the data type of the value that this function should return. So now that you specified that this function returns value, you have to use the return keyword inside of that function to actually return a value of that same data type that you specified. So now let's go back to our playground and see how this applies to the function that we have there. So let's say that for this function, I don't want to print out the sum. Instead, I wanted to return the sum to me. I would then erase this print statement first of all. After the rounded brackets, I would put hyphen, greater than sign, and then I would put int, specifying that this function should return an int data type. Now Xcode immediately throws an error here because it notices that I don't have the return keyword. I'm not returning an integer value like I said I would. So what I would have to do actually to fix this is use the return keyword, and I'm going to return C because that's the sum of A and B. So now when I call add two numbers like that, it actually returns C. Now let me show you something here. So when I type that, autocomplete, it shows you the return value right there. It tells me that add two numbers actually returns an integer like that. So what I would do essentially is I would probably declare a constant, and let's call it sum, and I would say equals add two numbers. What's happening here is that I'm calling this function add two numbers, and this function is returning C, as in the sum of 1 plus 1, and I'm assigning that value into this constant called sum. So now if I print sum like that, I would get 2. So this constant sum, it stores the returned value from my function here. So one more thing I can do up here, instead of declaring this constant C equals A plus B and then returning C, I could actually get rid of this constant and I could just return A plus B like that. And that would actually take A and B, add them together, and then return it. So that's return values for functions. And this is really powerful because now you can write a function that does something and returns the result to you. So your function is kind of like a little worker or a piece of code that does a specific task and then returns you back the result. Now there's another cool thing that you can do with functions, and that's called parameters. See, this function by itself, add two numbers, it's always just going to add 1 and 1 together and return 2 to me. But what if I wanted this piece of code to be reusable for any type of numbers? I want to specify which two numbers I want to add together. So essentially what it is when I declare this function, I can specify in between these two rounded brackets. See, I mentioned in the previous video that we would use this. In between these two rounded brackets, we can specify that this function needs some input parameters in order to execute. So let's say that I'm going to declare this function and say that when you call this function, you need to give me two numbers as inputs. Now, when I call the function here, I would have to specify two numbers in between these rounded brackets. Okay, so before we actually do it, let's go take a look at what the syntax looks like for declaring these input parameters. So this syntax right here shows you what the function definition would look like for a single parameter. Now we're going to get to multiple parameters, but this is an example of a single parameter function declaration. So in between the two rounded brackets, you have an argument label. Okay, I'll explain to you in a second what that is. And then you have a parameter name, followed by a colon, and then followed by the data type of the parameter you're accepting. Now let's talk about the parameter name colon data type part first. So obviously the colon data type part of that specifies what sort of parameter you're going to be passing into the function, and the parameter name is going to be the name of that parameter you use within the function. So if I wanted to take that input and I wanted to add it to something and I wanted to reference that value that was passed in, I would use the parameter name, okay, inside the function. Now the argument label for that parameter is what is going to be shown when you call that function. I know it's a little bit confusing right now, but let's jump into an example so it makes more sense. All right, so back to the playground here. Let's implement one parameter inside our add two numbers function here. So I'm not going to use any descriptive names right now because I want to show you how the argument label and the parameter name plays out. So I'm going to say add two numbers, argument label is, let's just say arg, and then the parameter, I'm just going to say para, okay, and then colon int. So this function now accepts a parameter that is type of int, and then Xcode detects that now this function call is incorrect because we have no function that doesn't accept parameters. So one cool thing you can do is just erase that and go add two numbers, you can see that autocomplete now recognizes that we have a parameter. So let's double click that, and you can see here is the argument label. Let's pass in a number here. Let's pass in 2, like that. So by specifying arg there as the argument label for the parameter, when I call the function, I'm going to have this label here. If I wanted to use this number that I passed in, remember you have to use the parameter name. That's for inside the function. So I would reference the value that's passed in using the parameter name like that. So essentially what I would get here is, because I'm passing in 2 and I'm setting a as 2, right? That's our parameter that just got passed in. It would be 2 plus 1. So that's what is stored into sum. And when I'm printing sum, that's what I expect to get, 3. Okay, that is helpful, but it's not complete. We want to be able to pass in both numbers so that we can specify which two numbers to add together. Let's take a look at the syntax for multiple parameters. So the syntax for multiple parameters is very easy. In the parameter list, that is that stuff between the rounded brackets, you would just put a comma after the first parameter and then essentially repeat the same thing for the second parameter. You'd have an argument label, followed by space, followed by a parameter name, colon, and then the data type. Now you want to use different argument labels and different parameter names, obviously, so that you'd be able to tell it apart. Now let's jump back to the playground and add our second parameter. So what I would do in between these rounded brackets in this parameter list is I would just put comma, and then I would put my second argument label, my second parameter name, followed by the data type, which is another int. Now again, Xcode is going to throw this error here. Let's use autocomplete again. Add two numbers. You can see here it's been updated to accept 2 arguments. So argument just arg and arg2. So let's pass in 2 and 2. Now we have to modify our code a bit. Right now I'm still getting 3, and that's because inside this function code I'm not using the parameter 2 yet. We can change that like that. So now A gets set to parameter, para, and B gets set to para2. And then I'm returning A plus B. So now I actually get 4 in here. So one thing we can do with this function is actually we don't need to declare A equals para and B equals para2. That doesn't really do anything. So we can get rid of these two constants here, and we can simply return para plus para2 like that. Straight off the bat, now our function is pretty simple. So at this point you might be wondering, why is it so confusing that I'm using argument labels here in the function call, and then we're using parameter names inside the function code? Well, what you can do is you can actually not specify argument labels like that and just have the parameter names. And what it'll do is it's going to use the parameter name both as the argument label and the parameter name. So now this is wrong. You can see Xcode here has an error. Let's use autocomplete to see what the new function looks like, the new function call. And you can see here that now the argument labels are the parameter names. So we can also change our parameter names at this point. You probably don't want to use para and para2 for your own function, so we can say, number 1, number 2. If we have these as our parameter names, then this changes as well. Number 1, number 2, and then our function call would also change like that. Okay. Now you might be wondering, why use argument labels at all? Like, what are they for? Well, using argument labels, you can make your function calls a little more like natural English. So let me show you an example. You can do something like this. Add 2 numbers. So there's my first argument label. And number 2, like that. So let's take a look at what our new function call would look like. So when I'm calling a function, add 2 numbers using 2 and 2, right? You can see how that reads more like natural English, and it makes intuitive sense what the parameters are going to be used for. Meanwhile, inside our function here, if my parameter names were using, right, or and, it doesn't make much sense, right? You know, if I used these as the parameter names like that, these would be terrible parameter names, because if my function is really long, this doesn't tell me anything, this doesn't tell me anything, it doesn't mean anything to me. While this function call still makes a lot of sense when you call it in terms of natural English, but in the actual code in here, in add 2 numbers, you know, adding using an and doesn't really make sense. So if you use the combination of argument labels and parameter names that make sense, you have this function call that is like natural English and makes sense, and you also have meaningful parameter names that you can use inside of your function. Okay, so I want to show you one more thing. If you don't want to use these argument labels at all, what you can do is replace your argument labels with an underscore like that. Or you can replace one, or you can replace both. So let me show you what that looks like. So I'm going to replace both the argument labels with just underscore. Let's take a look at what that looks like now. So you can see now that I just pass in 2 and 2 like that. No parameter names, no labels, no arguments, no nothing. It's just you pass in the input parameters like this. And these are your parameter names, so that's what you're going to be using inside of your function. Okay, so just to recap, in this lesson, you learned about return values, you learned about the return keyword, and you learned about input parameters and how to specify them, what argument labels are, what parameter names are, and also how to omit argument labels altogether. I hope you enjoyed this lesson. If you did, please give the video a thumbs up and please subscribe for more. Hello, welcome to Learn Swift for Beginners Lesson 9. In this video, you're going to be introduced to classes, which is an absolutely critical part of the Swift programming language if you're going to be using it to build apps. I'll tell you all about it. Let's get started. So I'm going to start off with a hypothetical example. So let's say you have something like a blog post which you would like to represent. We might have something like a variable here for blog title, right? Blog title can be Hello Playground. I don't know what kind of article that would be, but we would have another variable for the blog body, and this is the text of the article or the blog post. And then we might have something like blog author, which in this case, let's just put my name here. So you can see here, this is the data for one blog post. Now let's say I had 2 blog posts. What would I do in this case? I might have another set of variables down here, and of course I can't have the same variable names, so let's just append 2 to these variable names. And let's say this is, I don't know, this article is Goodbye Playground, okay? Now this is what I have for 2 blog articles. Now what if I had 10? What if I had 100? How many variables would I have then? It'd be a ton, right? It'd be a mess. There needs to be a better way to represent a blog post, to kind of group these variables together. And there is. In fact, that's what a class is. You know how you learned about the different data types back in lesson 2? You learned about the string data type, you learned about the int data type, float, double, boolean. All of those are data types to represent different types of data, right? Well, with classes, you can define your own custom data type. So what we're going to do here is we're going to create our custom data type called blog post, for example. You can do that with classes. Let's take a look at the syntax for declaring a new class. So first of all, you have the class keyword. Next, you have the name of the class, and this is going to be the name of your data type. Then you follow by 2 curly brackets, and inside those 2 curly brackets is your class definition. Let's take a look at this back in our playground. So, for example, up here, let's create and define our class. So first, I would use the class keyword, and then I would create a name of the data type, or the name of the class. In this case, let's put blog post, and notice that this time I'm starting off with a capital letter. In fact, all of the data types in Swift start off with a capital letter, so we should follow the same convention. Always start off your class names with a capital letter, and that's different from what we've been doing with variables and constants and functions. Okay, then I have these 2 curly brackets like that. What do I put inside of my blog post class? Well, why don't we put this stuff right here? I'm just going to cut it, and I'm going to paste it inside here. And then I'm going to delete this right here. And I am going to delete this text inside these variables inside my class and leave them empty. And I'm going to explain why in a second. Okay, so just like that, we've defined a class called blog post. And this class has 3 properties. Now, a property is just a variable declaration like this, but inside a class, it's called a property. And you're going to see why in a second, why it makes more sense. And because this blog title, blog body, blog author is inside of blog post, it's kind of redundant to name them like this. So I'm just going to name them title, body, and author like that. Okay, so this represents our blog post right here. Now that you've defined what a blog post is, let's create an actual blog post. Because remember, this class definition right here, this is just a definition of a data type. You're defining what a blog post data type is, right? So that's not an actual blog post. Just like how this is a string, that's not the definition of a string, that's an actual string. So in order to create an actual blog post, we're going to type in the class name followed by 2 rounded brackets like that. And just like that, this is a new instance of the blog post type. And it's called an object or blog post object. So when you define a new class using the class keyword, that's what's known as a class definition or just class. But when you create actual instances of that class, those are called objects. You can think of your class definition as a template or a blueprint, and you use that template to create actual tangible blog post objects. So let's jump back to the playground here. This is a very important concept to understand. We've defined a class called blog post here. It's got these 3 properties, or you can think of them as attributes of a blog post. And then down here like this, we've created a new blog post object. Now this blog post object has a title, it has a body, and it has an author, but all of them are empty right now. So what we're going to do is we're going to assign this blog post object into a constant. Let's call it my post, like that. So what we've done here is we've created new blog post objects, we've assigned it to my post, and now why don't we try setting the title of this blog post and the body and the author. What we would do is say my post, right? That's referring to this new object, and then we press dot, and that lets us access those properties which we've defined in the class definition. Set the title to, I don't know, Hello Playground. I think that's what we had before. Let's set the author of this one, and let's set the body to hello. Okay, just hello. Now, if I print my post dot author, I would get my name. Now let me show you something else. We can create a second instance of blog post, or a second blog post object, and let's call this my second post. And we're going to set this to a new blog post object like that. And we're going to say my second post dot title equals goodbye playground. And we can set the author to someone else. Let's say John Travolta. I don't know why that suddenly popped into my head. And let's just do hello again. Now, this is a second my post object. This is different from my post. These are completely two different blog post objects. Both of them contain these three properties which we can set because that's what we've defined here in this class. Now, another very cool thing about classes is that you can put functions in them. Right? You can see how all of the lessons so far are coming together. Let's create a new property for this first. Let's say number of comments equals 0. This is the number of comments in the blog post. And we're going to define a new function in this blog post class. We're going to say add comment, okay? And we're not going to worry about the comment text just yet. Let's just define this. So notice that in my function definition, I have these two curly brackets again. Inside here, this is going to be my function code. So inside this function, I am just going to increase the number of comments by 1. This is all stuff that you should have learned already in the previous lessons. Now, okay, so now every single blog post object is going to have this function. Now, how do we access it? We simply go my post dot, you can see now in the autocomplete that there is this function called add comment, and it doesn't have any return value. It doesn't return anything, so the return type is void right there. Let's call this function, okay? See what happens. So add comment, you can't visibly see what happens, but let's print my post dot number of comments. You can see that it's 1. Okay, now let's print my second post dot number of comments. What would you expect this to print out? It prints out 0. Why? Because we haven't called the add comment function on my second post. We just did that with the first post. Each of these blog post objects maintains its own properties. Changing the properties of one object does not affect the other. Even though they're cut from the same cloth, right? They're both types of blog post. They're two independent entities and they maintain their properties separately. Now, there's a lot more to classes, but fundamentally, I want you to understand what they are. So I'm not going to make this video any longer than it needs to be. I just wanted to introduce classes to you. I hope you can see why classes are a fundamental building block to organize your information. So thanks for watching. Please give this video a thumbs up if it helped you, and please subscribe for more. Hello, welcome to Learn Swift for Beginners Lesson 10. In this video, you're going to learn about inheritance, otherwise known as subclassing, which allows us to build upon previous classes which we've already defined, and it saves us a lot of time and effort and work so that we don't have to keep defining classes that do similar things. Okay, so let's get started and see how this works. Let me start by doing a small recap of what you've learned in this series so far. So you learned about variables and constants to store and keep track of data. You also learned about some control flow and conditional statements so that you can express logic and make decisions with your code. And then you learned about functions where you can define blocks of code that perform specific tasks as a way of organizing your code into more manageable chunks. And then you learned about classes, which is a further way where you can organize related code and related functions together, as well as related variables in the form of properties. And then today you're going to learn about inheritance, aka subclassing, as a way to further organize your code. Okay, so let's take a look at inheritance in a playground. So I'm going to launch Xcode here. I'm going to get started with a brand new playground, and let's call this inheritance playground. Okay, let's just save it on my desktop there and get rid of this line of code. So let's say that the app we're building is kind of like a car simulator or something like that, and we need to define a class that represents a car. So we're going to start by creating a car class just like that, and some of the things that it may have is, for example, it needs to keep track of a top speed, right? Because different cars may have different ranges for the top speed. I'm just going to initialize that to 200. So there may be a whole ton of other attributes or properties to do with cars, but for demo purposes, I only need one, so I'm not going to go further than defining top speed there. And I want to define a function. So a car, by definition, is a vehicle that can be driven, right? So I'm going to create a function called drive. Just like that. It doesn't accept any parameters. And inside this function, it's going to perform all the code that we need to drive a car. But, for this demo, I'm just going to print driving at, and then I'm going to put in top speed, like that. So this this value in this top speed property gets substituted in there, and then it prints out driving at whatever this value is, 200. So when I call the drive function, it's going to print this statement out into the console. Okay, so we've defined our class here that represents a car, and in the previous lessons you've learned about how to create a new object, right, from the car class. So why don't we declare a constant called myRide, and we're going to create a new car object and assign it into the constant myRide. Just like that, we've created a new car object. Now let me try accessing top speed, right? You press dot and then you can access the property there. So you can see it's running the playground. Okay, you can see 200 there. And let's try calling the function myRide.drive. Like that. And you can see it says driving at 100. Okay, so now let's say that in this driving simulator app, I also have something called a super car, or maybe a future car. So it's the car of the future, for example, and it can fly. So it's the flying car that it will probably come in the future. So we can define another class to represent that, and we can call it future car, right? And again, this future car, because it is a car still, it's going to have a top speed, and let's say this top speed is 250, like that. And it's also got a function called drive, because you can still drive this car. And again, it's just going to print, driving at top speed. And also, this car can fly. So let me define another function that represents, flying the car. So flying, I'm just going to call it flying, like that. So here we've defined our car class. We've defined a future car right here. If I want to create another, let's call it my new ride. This is a constant, and this time I'm going to create a new future car object, like that. And then my new ride, you can see, has fly now, right? And it has drive and it has top speed. Now, let me ask you this question. See, you can see the similarities between car and future car, right? They both have the properties of a basic car, like a top speed, and they both have this drive function, which is very, very similar. In fact, it's actually identical. So this is pretty redundant, right? There's a lot of redundancy between these two class definitions. So this is where inheritance or subclassing comes into play and is very helpful. So what inheritance allows us to do is say that one class inherits from another class. And essentially what that means is that if future car inherits from car, it's going to inherit its properties and functions, so you don't need to redefine them inside future car. So let me show you what I mean here. In future car, let's delete this top speed property and let's delete this drive function. And what I'm going to do instead is I'm going to make future car inherit from car. And the way you do that is after the class and then class name, you put colon like that, and then you put the class that it inherits from. So in this case, I would put car. So in this sort of relationship, we have car at the top, and we have future car at the bottom inheriting all of the properties and the functions from the car class. In this case, future car would be called a subclass of car, and car would be called the superclass of future car. And some people might call it the parent class. So car is the superclass or the parent class, or maybe simply the parent of future car. Let's go back to our playground and take a look at what this means for our code here. So you can see that my ride is still a car object, and it still has top speed and it still has drive. But take a look at my new ride, right? It's a future car object. And remember, inside future car, we've just defined fly. We haven't defined anything else in here. But if I type in my new ride and I press dot here and let autocomplete do its thing, you can see that future car actually has a drive function and actually has a top speed. So, if I do top speed, you can see it's 200. And if I do drive, you can see that now future car, or my new ride rather, is also driving at 200. And furthermore, actually, my new ride can also fly. Okay, so there's flying. Now there's actually a problem here, because right now my car and my future car, they're both driving at the same speed. But remember, the future cars are faster, right? Initially I wrote the top speed was 250. So in this case, what we can do is to do something called overriding. And that allows you to take a function or a property from the parent class or the superclass and redefine it to, essentially, that's where the word override comes from. So you're overriding the parent's version of that function, and you're providing your own implementation or your own version of it. Now, let me just do it here so you can see what it means. So we use the override keyword like that, and then we have to declare drive exactly as it is in the parent class. So what we're doing is we're going to say print driving at, and we're going to instead say top speed plus 50, because this guy goes faster. So now you can see that when I call this guy, when I call future car.drive, it doesn't use the parent class's drive function. It uses its own overridden definition of what drive is. Right, so this is the code that it's running here, and you can see it's driving at 250. Okay, so that's an example of overriding to provide your own custom functionality. Now inside this overridden method, there is a way that we can access still the parent functionality, and you can do that by using the keyword super. So let me show you what I mean. Inside this overridden drive function, I can actually access the parent class, the definition, all the functions and properties in there. If I type in super dot, and then I can access drive. So when I do this, super refers to the parent class or the superclass, and this drive function is actually calling this guy up here. Right? So in this case, it doesn't make sense. You can see in the console, when I type in futurecar.drive, it calls the original definition of drive, and then it prints this, its own definition of drive. So, in this example, it doesn't really make sense, but sometimes when you're building your apps, what you want to do is add functionality and not override the functionality, if that makes sense. So you don't want to replace what's in the parent class, you just want to add to it. And so you can do that if you can call the original definition, and then you can add your own code before or after that to provide additional functionality. So in this case, maybe I'll just change the statement here, and rockets boosting at 50 or something like that. So let's see. So now you can see that this is my original car, right? When I call drive, it says driving at 200, and then my future car is driving at 200, and it's doing something extra. Right? So that's how this overridden function works. Okay, so this is a simplified example of how subclassing works, but it's essentially how it works, and it's very predominant in the Swift programming language, as I'm going to show you in the next lesson. As you can see, inheritance allows you to save a lot of work by taking what's already there and then improving it or providing alternate definitions, so you don't have to redefine everything all over again, but you can build upon the classes that you already have. Okay, thanks for watching. Please help me continue to create more videos for you by giving this video a thumbs up and subscribing to the channel. Hello, welcome to lesson 11 of the Learn Swift for Beginners series. In this lesson, I want to introduce to you UIKit. It's an Apple framework that contains many of the classes we're going to need in order to construct iOS apps. Alright, so let's dive in and see what's available in UIKit. So like I mentioned in the intro for this video, the UIKit framework is essentially a library of classes that Apple gives us to build apps with. When you think about it, there are a lot of common elements to any sort of app. For example, apps may have views, they may have buttons. All apps are going to have things that you need to present to the user. Apps are going to need to handle user interaction from the person using the app, and so on and so forth. So to build that functionality out every single time you're going to build an app is extremely tedious, and not to mention complex and complicated. So Apple has provided UIKit for us to use, and it contains a ton of pre-built classes for us to handle all of these common things. So here I'm looking at the UIKit reference guide, which contains a list of all of the UIKit classes that are available for us to use. I'll link to it in the description below the video, but if you want to look for it yourself, just go into Google and type in Apple space UIKit. Don't just type in UIKit, because the first few results for that query isn't the Apple UIKit, so just type in Apple space UIKit to find the correct one in the first result. It was also essential to learn about inheritance before I told you about UIKit, because many of these classes inherit from each other. They build off of each other, so they don't redefine things. And this reference guide used to be kind of organized in a hierarchy, so you could see which classes inherited from other classes, but since they've changed it and they've made it kind of a listing, so you don't get that. But I did a Google search and I found an image that I'm sure this is not the complete UIKit, because this image was from 2012, I think. Yeah, you can see here in the URL it's from 2012, but it does give you an idea of how the classes are organized. So you can see at the very top of this tree, if you can imagine this left side being kind of at the top of the tree, and this right side being the bottom of it. If you take, for instance, this UI button class, which represents a button that the user can tap on the screen, UI button inherits from UI control, which inherits from UI view, and if you just follow this line, it inherits from UI responder, and finally from NS object. So that UI button class is a culmination of all of that functionality, from that chain. And let me just take a little moment to explain it to you so you can see how that UI button class is finally constructed. So this NS object class is the root class of everything. You can think of it as the big grandfather or granddaddy. And what this NS object class does is it provides that basic functionality that allows you to create an object from a class definition. So that's something we went through in part 1 of the classes lesson. So this NSObject class kind of gives you that functionality. And if we take a look at what was the next one down the chain, so the UIResponder class. So this UIResponder class inherits from NSObject, means that it contains that foundation that's going to be needed by all of these UI elements or user interface elements. Okay, so the next one down is a UI view. So UI view inherits from UIResponder, which inherits from NSObject. So UI view gets all of that functionality, and on top of that, the UI view class provides functionality for displaying something onto a view. So a UI view is something that you can show to the user. So it contains all of that functionality and code. And then next, in that hierarchy down to the UI button, we have UI control. Now UI control contains all of that functionality before it, following this line here. And on top of that contains basic code and functionality for a user element control. So stuff that is specific for displaying onto a view, handling user interaction and events, and responding. So then we have a specific type of UI control, and that is the UI button, which is pretty self-explanatory. It looks and behaves like a button with certain button events. So that's just one example of the path. You can see that there's a whole ton of classes, and there's even more now. So whenever you go and before you go and do something with your app, chances are you can probably leverage something from UIKit to build off of rather than building something from scratch. So in this video, I just wanted to give you guys an introduction to UIKit because we're going to be using a lot of classes from here, and every time I do, I will try and remember to reference this guide or at least link to it so you can take a look at these classes. It's very useful and handy to have at your fingertips because you can click into these classes and then you can find out for this UI button class what sorts of functions it has and properties it has that you can use and leverage, and how you can perform specific things with the button or with that class. And furthermore, I might do another video series where we go over specifically different UI elements because I think that would be useful for beginners to understand how to use, for example, like a date picker or a text field or a slider or a switch or something like that. So that might be a separate series on just UI elements. Please give this video a thumbs up and subscribe to my channel to help the channel grow. Hello, welcome to Learn Swift for Beginners Lesson 12. In this video, we're going to talk about initializer functions for classes. These guys exist to make sure that when you create a new object from your class, that object is ready to be used. Plus, you can customize these initializer functions to set up the object any way you want when you create a new instance of the class. Let's get started and see what that means. So what I've got here is a playground, and I wrote down a basic class here called person. And this person class has got two properties right now. It's got a name property, which I've initialized to an empty string. And also it's got an age property, which I've set to 0, and that is an integer. Now you learned about classes in a couple of lessons back, and you learned about how we create objects from classes, right? And in order to create a new person object, I would say something like var, let's just use the variable a equals person, like that, and we open up and close brackets beside the class name like that. And here I've got a brand new person object, and if I go a.name, you can see that it's an empty string, and if I go a.age, you can see that it's 0. So what's actually happening when you create a new person object here and you write these brackets? Don't these two brackets look like you're calling a function? But actually what's happening is you're calling the initializer function of the person class. But you might ask, we don't have one defined in here. What initializer function are you talking about? Let me write it out. By default, it exists. And if you don't customize it, you don't really have to touch it. but that initialization function looks like this. It just uses the keyword init, and it has these two brackets, and then in here, in between this, just like a function, you can define code in here to set up your object. So what's happening when you create a new person object with this line of code here is you're actually calling this init function of the person class. And inside here, you can actually write code to customize things. So for example, I can say name equals Chris and age equals, I believe I'm 33. I think I've lost track. But so what's going to happen here when I create a brand new person object is it's going to call this init function, and it's going to set these two properties to these two values here. So as you can see now, name is Chris and age is 33 when I create a brand new person object. Now remember how I said that you can actually customize the init function to set up the object the way you want it to be set up. And we can do that simply by adding some parameters into this init function, just like we would for any function that we set up. So for example, I can say n is a string and a is an int. So now I have to pass in these two values. So let me just erase this part here, and I'm going to create a new person object, and now you can see that the autocomplete shows me this. So for name, I pass in Chris, and for the int, I'll pass in 33. But instead of setting this stuff to the hard-coded values now, I can set up to what is being passed in here. So that's n, and that's a, right? When I'm creating a new person object here, I'm passing in these values that go in through this init function, and then it sets the properties to those values which I pass in. Now remember, if I don't want these parameter labels, all I need to do is go like that, and we learned this through the functions lesson, so you can review that if you forget why this is. These are the argument labels. By putting underscore there, we're basically saying we don't need the argument labels. Now, while we're on this topic of specifying these parameters here, oftentimes, and sometimes I catch myself doing this too, is that when we're passing in these parameters, the name and age, and you're intending to set it to these properties here, there's a tendency to name these parameters exactly like the property names, because after all, you named these property names to be descriptive, right, of what they represent. So in the parameters, you might be tempted also to name them the same thing. Well, what happens is you get into this situation where you're trying to set this parameter into this property name, but they're both named the same thing. So it's a little bit ambiguous. So that's where you can use this keyword called self, and how you would use it is you would say self.name equals name. So self refers to the object that is being created. So you're saying to set the name property of the object to this name parameter. So that's how you distinguish between if the property name and the parameter name is the same. So I would do the same thing here like that. So then this age refers to that guy, and self.age refers to the actual property there. Now another thing I want to point out is that I can no longer call person like that because there's no init method like that. Well, what I can do is I can actually have multiple initializer methods. So if I do this, let's say this is var b equals this person object. Well, this b.name is empty and b.age is 0, right? Because these guys haven't been set. After all, I'm calling this initializer function here that doesn't set anything. Whereas this guy, this initializer function, actually sets the name and age to whatever we pass in. Now there's one very important thing we haven't talked about yet regarding init functions. I mentioned in the intro to this video that the init functions are there to make sure that the object is properly initialized and all of its values are set, making the object ready to be used. So in this case right here for the person class, I've declared two properties and I've already preset them or initialized them to these values here. So really the init function has nothing to do. Even if I did nothing, as is in this case right here, the object would be ready to use because these properties have values. In the next lesson, I'll show you how you can sometimes, if you need to, declare these properties. In that case, when you create a new person object, the init function would be responsible for making sure that these guys do have a value. Because if not all of these properties are initialized to values, then the object is not considered to be ready to be used. So the init function is there to make sure that the values are set. And like I said, so far you haven't learned about how to declare these properties right here without setting them to values. I've always have set them to something, but in the next lesson you'll learn how to do that. And then we'll dive a little deeper into initializer functions and talk about how there are two types called designated and convenience initializers, and so on and so forth. Okay, so thanks for watching. Remember to give the video a thumbs up and subscribe to the channel if you haven't already. Hello, welcome to lesson 13 of the Learn Swift for Beginners series. In this video, you're going to learn about optionals, and it's probably one of the most confusing things for beginners. If you've ever looked at Swift code and you've noticed exclamation marks or question marks in the code, then you've come across optionals. So let's get started and find out what it's all about. So right here, I have a playground and I have declared a class blog post. In fact, if you've seen episode 9, the first lesson on classes, then this is going to look familiar because this is the example that we used for lesson 9 when I first talked to you about classes. Now, we declared a couple of properties up here for our blog post class, and these properties, they represent certain things about what a blog post might have. So for example, the title, the body, the author, number of comments, and you can actually safely ignore this function. So I'm just going to remove it because we're going to focus on this stuff up here. You'll notice that each time I declare a property right here, I immediately initialize it to a value. So title, body, author are all initialized to an empty string right when they're declared, and comments is set to 0 right when it's declared. Now this is all fine and dandy, but what if you actually want some of these properties to be empty? For example, what if I want to tell if the blog post has an author or it doesn't have any author? You might argue that, well, I can just check if author is equal to an empty string, and if it's equal to an empty string, then maybe there's no author. Well, what if the author isn't actually a string? What if it's actually, we have another class here and we call it person, and let's say that there's a name and we'll initialize the empty string. But, okay, so in this case, person is assigned to author. So, blog post has an author because it has this person object. So how do we distinguish there being no author for a blog post? Well, you have to be able to declare an author property and leave it empty because some blog posts may not have an author. So the way to do this is, if you remember from way back then, maybe lesson 2 on data types, I think, you can actually specify for your variables the specific data type that it can store. If you don't specify it, basically the data type is inferred from what you assign into it. Okay, so for example, if I wanted the title to be able to be empty, I would have to declare the type. I'd get rid of this equals empty string because we don't want to assign anything to it, right? We want to declare this property but leave it empty. I would do it like that. I would do the colon, specify the specific type, and then I would put question mark, and that is an optional right there. So when I declare this, title is empty, and this part basically tells us that the data type of title is string, and this question mark attached to the string data type tells us that it could be nil, which means nothing or empty, it could be nil, or it could actually contain a string. So contrast this with the body property here. This, when it is declared, is assigned this empty string. So it's always going to have a value, right? Whether it's empty string, or maybe in the future we assign some text into it, it's going to have some text. But, you know, this title property could be empty. In fact, it is empty right now as we declare it. So going back to this example with the author, potentially some blog posts may not have an author, so we can't just, you know, initialize the author property to a person object, because that would mean all blog posts at least have a person attached to the author, right? We want to make this property able to be empty, right? So the way we do that, again, is we specify the specific data type, put the question mark there next to the data type, and we get rid of that part because we don't actually want to assign anything to it. Okay, so in this way, we have a blog post class which has an optional title property, has a body which is initialized to an empty string, so it at least always has a value, and it may or may not have a person. You know, it could have nobody assigned as the author, or it could actually have a person object assigned as the author, and number of comments will always have a value and starting at 0. So you're going to want to pay attention now, because I'm going to tell you how you should think of these optional properties that we have here. And this is sort of metaphor or visual that you can think of that I was taught when I was learning this stuff. And that is to think of the title property, this optional string. It could optionally contain a value or not. Think of it like a box. It's labeled string, but you can't see what's inside the box. You don't know if there's actually a string object inside, or it could just be an empty box. Right? It could be an empty gift box if you've been really bad and someone gives you an empty gift for Christmas. That's never happened to me, but if it has to you, let me know in the comment section below. But anyways, you can think of an optional property like a box that may contain the actual object, or it may not. So how can you find out if there's actually the string object inside or not? Well, you have to unwrap that box, right? You have to unwrap that gift in order to look inside and see and get at the actual object. And that's exactly what we have to do in code now with our optional properties. So let me create a new blog post object here. Let me say post equals blog post, like that. And what we're going to do here is we're going to say, hey, print out post.body plus I don't know, plus hello, something like that. Okay, so it basically just prints out hello because body is empty, but let's just assign it to something like that. So then we have something like hey hello, right? That totally makes sense because body, we've initialized it to hey, right? When we create the blog post object, it's already set to hey, and then we concatenate hello to it. So when we print post.body plus hello, you know, you're accessing that property and then you're appending hello. Anyways, that makes sense. So we can no longer do that with something like the title, right? Because that's an optional. It's wrapped up in a gift box and you don't know if it's empty inside or if there's actually a string object inside. So you can't blindly use it. You have to unwrap that gift box and check if there's a value or not and then use it. So now, before we use title, we have to check if there's actually a string object or if there's actually a value inside that optional. And the way we do that is we do something called optional binding. Okay, so it's kind of like an if statement. So you say if, but then you use the word let. And if you remember, using the keyword let is declaring a constant, right? In fact, that's exactly what this is. You're declaring a constant here. If let actual title equals title, and then you open up these curly brackets. So what you're doing here is you're testing, sorry, not title, I meant post.title because this is the optional property here. What you're doing here is you're saying that you're testing, you're unwrapping this this title property, this optional, and you're saying if there is a value in there, then assign it to this constant called actual title, and then inside here you can use actual title as the value. But if there is nothing inside this optional, and if you unwrap it and it's empty, it's nil, then don't execute this code inside. So that's why it has an if statement here. You're basically testing to see if there's a value inside this optional. If there is, you assign it to this constant, and then you use this constant inside here. If there isn't, then it's just going to skip over this whole if statement. So in here, we can safely now, we can say, print actual title plus, I don't know, 𝗩𝗶𝗱𝗲𝗄. So there is no value in title, so it actually skips all this. But let's say, for instance, we say here post.title equals yo, like that. So now you can see when it does this optional binding and it unwraps this title, because we have assigned something into it here, it finds that, hey, I unwrapped the optional, there is a value, I'm going to assign it to actual title. So inside this if statement, we can use actual title and do this. But if I didn't have this line here, let's comment this out, you can see that it completely skips this and it doesn't crash or do anything like that, because we're safely checking if there's a value inside that optional first, and then we're using it. Now there's always different ways of doing things. So in the Swift programming language, there's actually a way to be a cowboy and skip all this. If you don't want to check it and you just want to use the value, there's something inside, what you can do is you can use, you're going to not check it, you're just going to use it. You can, it wouldn't be that, it would be post.title, and you put this exclamation mark. And this is called force unwrapping. So what you're telling Xcode is you're saying that, hey, I know there's a value in here, I don't need to check it, I just want to unwrap it right away using this exclamation mark, and I want to use whatever is inside of there. Right? In this case, it's yo. So here we're accessing post.title. It's an optional property. We don't care. We're going to force unwrap that, and we're going to take out that value and use it. And so if there is a value inside, you can do that. But it gets a little dangerous because, for example, if there happens to not be a value in there and you're force unwrapping it and you're trying to, use the value, well, there's an error because, and this is the error you get, fatal error unexpectedly, right? Because when you use this exclamation mark, you're expecting that there is a value, unexpectedly found nil when unwrapping an optional value, right? That's exactly what I was telling you. You're force unwrapping the title and you're trying to use it, but it was actually nil. So you actually get a crash. And in your career of building apps, you probably will see this error, unexpectedly found nil. So now you know why. So the safer way to go would be actually to use optional binding. So I'm going to press Command Z now, or Command Z for the Americans. I'm going to undo. All right. Do something like that. And this is optional binding. So another way where you can test before using is just, it's just with good old-fashioned if statement and testing if it's nil. So you can say something like testing for nil. You can say if post.title is not equal nil, then print post.title. And because you have tested it that it's not nil in this if statement, you can go ahead and force unwrap that and use it. Right? So that works. You can safely use force unwrapping because in this if statement, you've just tested that it's not nil. Okay? Now the reverse, if you want to check that it is nil, is post.title equals nil. Okay? It's not equals nil. A lot of beginners make this mistake and they use one equal sign, but 1 equal sign is for assignment. Remember that. So if we're going to test for nil, you're going to use 2 equal signs like that. And this is like optional contains no value. Okay, optional contains value. And in here, for optional binding, optional contains value. So as with all of the other things we're learning with Swift, we can go deeper. There's additional things to learn about optionals, like optional chaining and other ways of using optionals, but this is your introduction. I wanted to tell you about what the question mark means and what the exclamation mark, force unwrapping, and how to check an optional before using it. I wanted to introduce you to these kind of high-level concepts, and practically speaking, you'll be using them most of the time like this. And then in the future, we'll touch upon the more complex things about optionals. Also, you might be wondering why and when you would ever use optionals, but let me tell you, you definitely will use it when you're building apps. And when we do build our apps together, you'll know what they are, and you'll know how to declare optionals and how to unwrap them and how to check if they're nil because you've watched this lesson. Okay, so thanks for watching. And please subscribe and thumbs up and share the video with other people you know who want to learn Swift as well. Hello, welcome to lesson 14 of the Learn Swift for Beginners series. In this video, you're going to learn about properties, which is something that we have been using already together since the classes lesson, but we haven't formally introduced them yet. So this video is for that. In addition to that, I'm going to show you some other cool things you can do with properties that you can't do with variables. Okay, so let's get started. So here I have a playground which defines two classes, blog post and person. And you might recognize this from previous lessons. And in both of these classes, we've defined some variables here. Well, properties are nothing more than variables that are associated with a class like this. So for example, in this blog post class, I have a title property, body, author, and number of comments. And if I create a brand new blog post object from this class, let's say let my post equals new blog post, like that. And then in order to access this title property, I would use the dot notation. I would say my post dot title, and I'm going to assign something to this property, and let's just call it title of post, like that. And in order to retrieve that value from that property, I would just use dot notation again, and this would return the value inside that property. So you can see that a property is just like a variable where it stores a value and you can retrieve it. But I don't know if I mentioned this before, and that is that properties are independent between objects. So remember, we have defined this blog post class right here, and from this class, we can create many blog post objects. For instance, here I've created a blog post object and I've assigned it to my post. Now let me create a second blog post object. I'm going to call this my post 2, and I'm going to create a brand new blog post object from there. So I have assigned title of post to the title property of this guy right here, right? That doesn't affect my new blog post object. So I can assign my post 2 dot title equals another title, like that. And if I display this title, you can see that it shows another title. So the properties are really variables that are attached to the blog post objects that I create. And although each blog post object has a title property, the values that they store are independent of one another. Okay, so the second thing I wanted to point out with properties is that when you're working inside your class, so let's say we're working on this blog post class and we create some functions here. Let's say add comment, we're going to create a function like that. And we're going to create another function, maybe called share share article. Okay, these don't really have to do anything. I just need to create two functions for the sake of creating two functions to demonstrate this purpose. Okay, so just disregard what I'm calling them because they're not really going to do that function. Okay, so what I wanted to point out is that these properties that you define inside the class, they can be accessed inside any of the functions inside that class. So inside add comment, I might be performing some code to add a comment, and I would be able to access, let's say, I can print title or something like that, right? That would access this guy. Well, actually, that's an optional. So using what we learned, let me just force unwrap it. But my point is that I can access these properties here, or I can let's say, body, for example, and here, likewise, I can also print body. Right? Within all of the functions inside this class, I can access any of these properties up here, and I can set them too from within any of these functions. However, if you declare a variable inside of a function, that is what's called a local variable, and the existence of that variable is limited to the scope of that function. So what that means in plain English is if I declare a variable here, let's say var my comment equals some comment like that, I would not be able to access this variable inside this function here. So if I try to print my comment, you're going to see it throw an error here saying that my comment was never used. Oh wait, that's regarding this guy right here. So this is just an optimization. Xcode, this yellow little triangle means that it's a warning. It's not really an error, so it's fine. Xcode is just warning you that you declared this my comment variable and you assigned it something, but you never used it. So consider changing its name to an underscore, which is an optimization, but we are going to use it. So Xcode is just proactive because every time you're typing code, it just scans your code and it tries to tell you about these optimizations that you can do. Okay, so that's kind of a side note. Back to the main point I was trying to make, and that is if you look at this error here, use of unresolved identifier my comment. That means that Xcode doesn't know what you're referring to when you try to print my comment here. So even though we declared it here and we assigned it inside this function, this variable, because you declared it inside here, is the scope of this variable or its existence is limited to whatever is inside these two curly brackets. It's limited to the code inside this function. If I wanted it to be accessible everywhere, I would create a property and I would use that instead. So that's probably something you're going to get used to as you're doing more coding, is the scope of where you declare things. So this is called a local variable because we're declaring it inside a function, and these properties that we declare up here to hold values are accessible inside the whole class. So what that means is that, let me just delete these two functions for now. So what that means is that if you have a function that, let's say, calculates a result or performs some sort of calculation, like for example, add up comment total or comment counts or something like that. And the point of this function is to maybe sum up the number of comments that this blog post has. And then at the end of the whatever you're performing calculations here, do some calculations and come up with as a result. Arrive at a result. Now, what do you do with that result, right? You can either, and you learn this in the functions lesson, is that you can specify a return value. So this specifies that when you call add up comment counts, it's going to return a number for you. So now you can say, return whatever the result is. whatever variable it's stored in, right? You can return it to the caller. Another thing that you can do to make it accessible later on, because remember, any variables that you declare inside here are local variables and they live and die inside this function here. So if I didn't do the return value route and I arrived at some sort of calculated result and I wanted to save it for use for later on, I would probably assign it to a property. So I can say number of comments equals whatever result that I arrived at. And by doing this, when I call this function, it's going to do some calculations, calculate the result, the total number of comments, right? And it's going to assign it into this property. And now I can use the number of comments in other functions or later on. If I left it as a local variable, it would, again, when this function finishes, that would be lost. Okay, so that's the difference between the lifetime or the scope of property versus local variables. And now for the third thing that I want to show you in this lesson is something called computed properties. And it's one of those things that makes properties a little more special than just plain old variables here. So let me get rid of these two here so that we kind of start fresh and we're back to where we started in this lesson. You can do what's called a computed property, and what that is it just returns, and what that is it lets you do some calculation and return a result when you call a property. So let me demonstrate here. So let's say that we have let author equals person, right? So there is our author, and let's set the author's name to Chris Ching, which is my name. And now let's create a blog post. My post equals blog post. Okay, and now let's assign the author property of the post, right? Let's assign author into it. Now, author right here is this person, right? This person object that I created. And finally, let's set the title to, let's say, Learn Swift for Beginners. Okay, so what do we have here? We have an author object, which has the name set to Chris Ching. We have a blog post object with the author set to this person object that I created. And I also set the title to Learn Swift for Beginners. Now, what I wanted to show you is I'm going to create a computed property up here. And I'm just going to add a comment so that, just to make it stand out a little bit. So I can say var full title is a string, and I'm going to open up a set of curly brackets right after it. And what I'm going to say is check if title and author are not nil. Check that title and author are not nil, because title is an optional, right? And author is also an optional, and you learned about these in the previous lesson, so you know what they mean. They could return nil, which is nothing, right, when you unwrap it. So I'm going to use an if statement just to check. So if title is not equal to nil, and that's the double ampersand, which represents an and condition. So if title is not nil and author is also not nil, both of these conditions have to be true, then I'm going to run this code inside. Then return title. And remember, because title is an optional string, right? That means I have to unwrap it to get the value inside. And I'm going to use the exclamation mark to force unwrap it. That means I'm going to tell Xcode, I'm just going to unwrap that optional and use whatever is inside, whether it's a value or whether it's nil. And I know for a fact that it's not nil because I just checked it up here, right? So I can safely and confidently do this. So I'm going to say by and then plus, and I'm going to do the same thing with author. I'm just going to force unwrap it and use it. Okay, so let's see what it's saying here. Cannot be applied to string and person. That's right. Okay, so author is a person, right? So I can't I can't append a person object to the string. What I meant to do actually is I meant to unwrap the author, right, to get the person object, and then call its name property. So that's what I actually wanted to do. Okay, so right here, Xcode is complaining that missing return in a function expected to return a string. So this computed property here, when it gets called, full title, it's supposed to return a string. And if title is not nil and author is not nil, it is going to return a string. But what if one of these things are nil, either or? In that case, I'm just going to use the else branch here. I'm just going to return, let's do another check. Else if title is not nil, not equals nil, then return just the title. Force unwrap that. Finally, if the title is nil, then I don't know what we can do other than return an empty string. Or let's say no title. Let's do that. Okay, so this is awesome. Now this is a computed property, and I hope you can see that from this demonstration what that means. It's a property where basically you can perform some code, you can do some calculation, you can combine a bunch of things and return a result, return something. So if I say down here, if I say my post dot full title, what do you think it's going to display? Well, let me print it out because it's kind of truncated over here. Let me use the print so it prints down in the console. It's Learn Swift for Beginners by Chris Ching. And I didn't have to set that, right? Because this is a computed property. This full title property is calculated by grabbing the title and appending by, and then appending the author name. And if we didn't have an author, so let me just get rid of this line here for setting the author. If we didn't have an author, it would just print out the title. And if I get rid of the title and it doesn't have a title, then it's going to print no title. And that's all of this logic here in my computed property. Okay, so that's computed properties. There's also additional things which we won't cover in this lesson. We'll probably do another video on properties, and that is getters and setters and property observers. But this is a really great start to taking a look at properties. So thanks for watching. Please like the video and please subscribe. Hello, welcome to lesson 15 of the Learn Swift for Beginners series. In this video, we're going to revisit initializers, and I'm going to tell you about designated initializers and convenience initializers. Okay, well, let's get started. So right here, I'm starting off again with the blog post class and the person class. And of these properties here in the blog post class, I'm actually going to uninitialize some of these properties so I can demonstrate for you what we need to do in the initializer. Because I mentioned before that one of the jobs of the initializer is to make sure that all of these properties are initialized and ready to go. So even if it is an optional, that is considered okay. When you're declaring your properties inside your class, there are basically three different ways of doing it. So number one is this one where you declare the property and you initialize it to some sort of value right away. So that's this body property right here, and this number of comments property is equal to 0. The next thing you can do is you can declare a property and set it to optional. So you're specifying that it could be nil or it could contain a value, but either way, you have to unwrap the value and you have to check if it's nil before using it. Now the third way is probably the most dangerous way, and that is using the force unwrap operator. So let me show you what that means. If I get rid of that question mark and I put an exclamation mark there, and let's also do it beside author. So what you're saying here is you're saying that title basically is an optional. It could be nil or it could contain a value, but you're going to leave it unwrapped. So when I access the title property down here and I say post.title, Xcode is not going to have that sort of safe checking or warning us that it could be nil. It's not going to provide any of those safety mechanisms, and it's just going to let us use it as is. So we can assign nil into title. As you can see here, it's nil. And we can use it like a normal property, right? We don't have to check if it's nil or not, or rather, it is up to us whether we want to do it or not. But however, if the difference, the flip side being that we make this an optional, now there are some safety mechanisms in place. If I just try to use this as is, Xcode is going to warn us that, hey, this is an optional. You have to check that it's not nil, or you have to unwrap it first before you can use it. So I might have to say if let actual title equals, and this is using optional binding. So basically we're checking if there's a value inside the optional first. If something could potentially be nil, it's probably safer to use an optional value so that it forces the programmer to actually check things before using it. Now, if you set your properties like that, then it could still be nil or it could contain a value, but you sort of remove that safety checking that optionals provide. Okay, so those are 3 different ways that you can set up your properties. What you cannot do, however, is you can't just do something like that, where you declare a property, you don't set it to anything, you don't specify that it's an optional, or you don't specify that it's unwrapped, and you just leave it like that. In that case, Xcode is going to assume that the initializer is going to set those to some values. So let's declare our initializer here like you've learned in the past. And inside here, you can see that Xcode is still showing errors. But if I actually initialize these things inside the initializer, let's say author is equal to person like that, then Xcode is going to stop complaining. Because remember, when we create a new blog post like this, it's actually calling the initializer. So even though these properties right here, title and author, they're not set to anything, they're not optionals, they're not unwrapped, this initializer is going to be called for sure when we create a new blog post object. And inside here, those properties get set to some value. They get initialized. And so at the end of the day, this blog post object is going to be ready to be used. Now this initializer right here, this is what is called the designated initializer. And what that means is that this initializer function is guaranteed to fulfill those obligations of making sure that all of the properties are initialized before use. In contrast, we can have something that's called a convenience initializer. And what that is you use the convenience keyword followed by your initializer method signature. So I might have something like this, where inside this initializer, I only want to provide a custom title. Well, you might ask, if I call this convenience initializer, how is author going to get initialized? Right? So what happens is inside the convenience initializer, I call the designated initializer using the self keyword like this. So now, and inside here, let's set title equals custom title. So now when I declare a new blog post object, and let's say I use my convenience initializer like this, and I pass in a custom title like this, it's calling this convenience initializer. But this convenience initializer is also calling the designated one, which makes sure that at the end of the day, the uninitialized properties will be initialized. And then after calling that designated initializer, then we set title to custom title. So whether I call this designated initializer or the convenience initializer, the title and the author properties will be guaranteed to be initialized. And so the role of the convenience initializer is simply for convenience. So that's the difference between a designated initializer versus a convenience initializer. Hello, welcome to Learn Swift for Beginners Lesson 16. Today you're going to learn about how to manage a collection of data in what's called an array. If you're working with many pieces of data, it would be hard to manage them with simply constants and variables. So let's take a look at how arrays can make our life easier. All right, let's get started. Now, arrays are one of three collection types that are available in the Swift programming language for us to use and manage our data. In this language guide, you can see a diagram of this array on the far left side. We're going to come back to this diagram in a second, but first a definition. So you can think of an array as a collection of data that is ordered by indexes. Now, if that doesn't tell you too much, let's jump right into a Swift playground, and I'll show you exactly how beneficial they are and also how to declare them and how to use them. So first, I'm going to delete this default variable here, and we're going to create a couple of variables ourselves. So let's say var a equals dog, var b equals cat, var c equals bird. And now let's say I wanted to concatenate or add the word my in front of each of those values there, so that I would have my dog, my cat, and my bird. So I would have to do something like this. I would have to go a equals my space plus a. And this would result in a being my dog, because we're adding the word my with a space to a, and a is dog. And then we're reassigning that result into a again, thereby overwriting what was there before. So now a is actually my dog. Now I would have to repeat this for cat, and I'd have to repeat this with bird. I can't even use what we learned in the previous lessons in regards to loops to make my life easier. I'd have to write this out 3 times for each of the variables. So here's the perfect chance to use an array to organize this collection of data. So in order to create an array with the data already in it, we're going to open up 2 angle brackets, or square brackets if you'd prefer, and inside these 2 square brackets we put each piece of data separated by a comma. So we have dog, we have cat, and we have bird. So just like that, we have an array with 3 pieces of data. And if you remember what I said in the definition, that arrays are a collection of data organized by indexes. What do I mean by that? Well, you can see that there are 3 pieces of data here. So there's 3 distinct spots, you can think of it. The leftmost spot here, the beginning, is index 0, or spot 0 if you'd prefer to think of it like that. The next one is index 1, and the last one is index 2. So arrays start at 0, and because there are 3 items here, the indexes go from 0, 1 to 2. And now if I quickly bring up that language guide again, you can see in this diagram that in this array there are 5 items, and so the indexes for 6 eggs is 0, index for milk is 1, and so on until it reaches 4, even though there are 5 items, because it's 0 based. Okay? So let's go back down here. So this is great that we have an array here, but we need some way to reference that array. So actually what we do is we can create a variable, let's call it D, and we assign this array, or this collection of data, into the variable D. So now if I wanted to access dog, for example, I would write D, and then I would write square brackets like that, and in between the square brackets I would put an integer representing the index of the item that I want. So let's say I want dog, I would put 0. So you can see here I would get dog, right? And so we can print that out, and that would print dog down here. Now if I change the index to 1, then I would get cat instead. Now let's do an example where we have something like this. Just to duplicate that, I would say, let's say a equals my plus d 0. Like that. I can do b equals my, that's my cat. And finally, I would get my bird. But then I mentioned that there was a better way to do it if we leverage what we learned in the previous lesson on loops. Well, we can. Let's take a look at using for loops and simplifying our work here. So remember, for loops will loop a piece of code for a specified number of times. And you can see here that I'm working with index 0, index 1, index 2. So this becomes really easy. I can say for, remember, the next piece of the for loop is a counter. So, it's my variable to hold the current index. And then you write in, and then you write your range. So I can write 0, 2, and this is going to loop from 0 to 2. So I think you can kind of see where I'm getting at. What I'm going to do is print my plus d, and inside here where I put the index usually, I'm going to put counter. And you can see here it took the playground a little second, but that's exactly what I expected to do here. So in the first iteration of this for loop, counter is 0, right? That's the starting range. So 0 gets passed into here, and I would get this printed out. This is dog. D at index 0, right, is dog. In the next iteration of the loop, counter is 1, and so I'm actually accessing index 1 of my array D. So that's why I get cat. And then finally it loops again, and counter is 2, and I would access this bird index here. I want to show you another way to use your for loop with an array, and that's simply to say for item in D. So what this is going to do is it's going to loop through all of the items in the array D, and in each iteration of the loop, it's going to take that item or that piece of data, and it's going to assign it to item. So I can simply go like this. So you can see that it gets printed out again. Right, in the first iteration, item is dog. In the second iteration, it's cat. In the third, it's bird. So this is a pretty simple way to write it, and you can see that it saves a lot of work from doing it kind of one by one like this and one by one like this. Arrays in conjunction with loops, really powerful stuff. Now with arrays, there's other cool things you can do. Let me just make some space here. Maybe I should delete this stuff. You can actually declare an empty array. So it's an array that would contain no data at first. And the way you do that is just like storing things into a variable or a constant. Arrays can only store data of a certain data type that you specify. So since it's an empty array, how you would do it is you open up 2 square brackets, you put the data type inside the 2 square brackets, and that data type represents the type of the data that the array is going to store. So I'm just going to put string here, and then you end off with 2 round brackets like that. And just like that, now E refers to an array that is empty right now, doesn't contain any data, with the intention of storing string type data in this array. Now, if you're going to create an empty array like this, you better be able to add data to that array, right? So what makes arrays really useful is that you can add and remove data from that collection. So I can add or remove from this collection right here. I can add or remove from this collection here. Let me just show you how to do that. There are a couple of different ways. I can do something like this. D plus equals two angle brackets like that again, and let's say I wanted to add mouse. And now my D array would contain 4 items, as you can see here: dog, cat, bird, and mouse. In fact, I can even add 2 pieces of data at once, comma, and then here I could put owl, for example. So it would add mouse and owl to that array. So now my array has 5 items from 0 to 4, right? Starts at 0, 1, 2, 3, 4. Make sure that you don't forget that plus sign right here, because if you do that, then essentially you're creating a brand new array with these 2 items and you're assigning it to D, and you've just lost this data here. So plus equal is for adding items. Now, seeing this plus equals, you might be tempted to use minus equals to remove items like this, but that actually doesn't work, unfortunately. You can't remove items from the array like that. What you have to do is the array actually has functions that you can call on it to remove items. So you would say D, and then you would press dot on your keyboard, or the period key, and out pops a list of functions that you can call on this array. And using the append function is going to do exactly like this plus equal is. It's going to add items into that array. But let's look at the remove functions. So you have remove all, which is going to remove all the items in an array. But you can use this one here, remove at, and you can specify the index of the item you want to remove. So if I put 0 like that, that's going to remove dog from my array. So now it's only going to contain cat, bird, mouse, and owl. Now, what if I don't want to completely remove dog, but I just wanted to change that element right there at index 0? So let me get rid of this remove line. You saw that you can access items in the array by doing that, right? Putting in the index there. Well, you can actually change the item. You can change what is assigned at that index by typing D, square brackets, put in the index you want to change, and using the equal sign to assign something new into that spot. So here, let's say turtle, and that is going to now change your array. If I print D, 0, I'm going to get turtle instead of dog because I just changed it up here. The last thing I want to point out is that arrays also, you can check how many items are in there if you look at the count. And that's going to return the number of items in your array. That is sometimes useful when you want to use a for loop with a range and you don't know how many items are in the array. You can use this array.count and get this number here. But just keep in mind that although D has 5 items right here, the index of the last item is actually only 4 because the first item is 0. It goes from 0, 1, 2, 3, 4, right? Even though there are 5 items. So just keep that in mind if you're going to use this array.count in conjunction with a for loop or something like that. Okay, so that's where we're going to end with arrays. As you can see, when you type array dot, there are a lot of different functions with arrays that you can do. What I've covered here in this lesson is enough for you to use arrays and leverage some of the main benefits of arrays. As we go on and we're building apps together, you're going to be learning new ways to use arrays. But for now, these are the main things you need to know about arrays in order to start using them. If you like this video, please give this video a thumbs up. Please subscribe for more. Hello, welcome to lesson 17 of the Learn Swift for Beginners series. In this video, we're going to go through another collection type called the dictionary. In the previous lesson, we went through the array you can see here on the left-hand side, and with an array, we had a collection of items where the order mattered. So you can see in this example here in the Swift Programming Language Guide, 6 eggs is in spot number 0, whereas bananas is in index 4. Right? Well, a dictionary on this right-hand side here is a collection type where order does not matter. So in arrays, we retrieve the item by this index here, and with the dictionary, because order doesn't matter, we retrieve these values using a key. So each value has an associated key when you put it into the dictionary, and you need to pass it that same key, and it's going to return for you the value. Now, which collection type you use to organize your data is going to depend on, obviously, what sort of data you're storing. Does order matter? If it does, then the easy answer is to use an array. If it doesn't, then maybe consider using a dictionary. So this is a good example. Airports have these airport codes, right? So each airport has an associated key. And that's a good point. The keys should actually be unique for each value that you put in. Another great example of when to use a dictionary, and this is the example that I'm going to use in this video, is license plates. So for example, each license plate is tied to a car, and each license plate is unique. So the key can be the license plate, and the value can be maybe a description of the car or something like that. Let's jump into Xcode in this new playground that I have here, and let me show you how to declare a new dictionary and how to work with it. So why don't we declare a variable here, and let's call it CardDB to represent car database. And let's looks like my playground has crashed. Okay, and what we're going to do here is to declare a new dictionary. So we use the keyword dictionary, and followed by that we have these angle brackets where inside we specify the data type of the key followed by the data type of the value. So for example, let's pull up that example again. In here, this dictionary, the key would be a string, and the value would also be a string. And so in between these two angle brackets, we would just put string, comma, string. And in order to create a new dictionary object, we would just end off with those two brackets. And like that, we have an empty dictionary, which stores key value pairs. And a key value pair is just a fancy name for one of these pairs of data, you know, a key and a value. This dictionary stores key value pairs where the key is a string and the value is a string as well. Now, there is an easier way to write this out without having to write so much. Let me show you that second way. Var CardDB, let's just say db2 is equal to, use the square brackets, and then you specify the data type of the key followed by colon, and then the data type of the value. And again, we have these two brackets here to create a new instance of that dictionary or new dictionary object, and that's equivalent. These two are the same thing. Doesn't this look very similar to declaring a brand new array? Don't get confused. So for example, declaring a new string array would look like this would be my empty array that is expecting to contain string objects. And this is an empty dictionary that is expecting to contain key value pairs where the key is string and value is string as well. Okay, so we're going to stick with this sort of declaration here. So I'm just going to go ahead, delete this array example that was just for demonstration, and delete that. So now we just have CardDB is an empty dictionary. Now, how do I assign something into the car database dictionary? Well, I would do CardDB, and then I would use these two square brackets here, and I would pass in a key, or I would specify a key rather, and this key would be a license plate, right? So, you know, this is going to be different depending where you are in the world, but let's just say it's like that. And then you assign the value into the dictionary for that key. So this would be, let's say, a blue Ferrari. Now, this value, blue Ferrari, is tied to this key, JSD238. How do I retrieve the value? Well, it's very simple. I just give it the key. So if someone were to look up this license plate, let's say I print this out like that, it would print out blue Ferrari. But notice that it's wrapped in an optional tag because, for example, if I passed in a key that doesn't exist, right? Let's pass in like ASD238, then you can see there is no value for that key, right? So that's why it returns nil. So that's why when you access a dictionary and you pass in a key, it returns to you an optional whatever data type that your value is. So when you pass in a key into your dictionary to retrieve a value, just expect that it is an optional and you may need to unwrap it and check if it's nil before using it. Okay, so what if I wanted to, let's label this. So before we continue on, this is declaring a new dictionary. This is adding key value pairs. And this is retrieving data. And how do we update a value for a key? Well, it looks exactly like this up here. So you specify the key that you want to update the value for. And here we can say that this guy now is a red Ferrari. Maybe it got a paint job or something. So when you pass in this key from now on, you're going to get this new value because this basically overwrote whatever was there before. And in order to remove a value, remove a key value pair, let's say, you can do something like this. You pass in the key 238 and you assign it nil. And actually, that is going to remove the key value pair from your dictionary. Now I'm going to show you how to iterate over all of the key value pairs in your dictionary. So why don't we just add a second key value pair in here so that we have more than one item to display. Okay, and this one can be a green Lamborghini. I think that's how you spell it. I don't have one, so I don't know for sure. And now let's iterate over it. Wish I had one though. Iterate over it. We use a for loop. So we can say for, essentially for each key value pair inside the dictionary, do something. And the way you specify this is you pass in, we use what's basically called a tuple, okay? And so you can think of a tuple as a set of variables or a bunch of variables. So we're going to say license car in car DB. Now the in keyword shouldn't be new to you because you guys learned about the for loop in a previous Swift lesson. So basically what should be new to you though is this. This is a tuple. So for each tuple in this dictionary, we can do something. What's going to happen is it's going to grab each key value pair, and the key is going to be inside license, and the value is going to be car, like that. So now inside this for loop, it's going to iterate twice, and I'm going to find this key or this license inside this license variable, and I'm going to find the car, this string here, blue Ferrari or green Lamborghini, inside this car variable. And it knows, even though there's no data type associated with this tuple, because my dictionary is string for the key and the value, I'm going to simply print car like that. And you can see that it's printing one key value pair here. It's printing one car, but I have two items. And the reason is because we've actually removed a key value pair with this statement here. So if I just comment this guy out, we have our two cars. And it's a red Ferrari because we changed it up here. Now I can also print out the license. I can say, you know, license I can say something like car has a license, like that. Has a license. So that pretty much wraps up using a dictionary, and you're going to find that it will come in handy alongside arrays in organizing your data. So thanks for watching. If you like this video, please give it a thumbs up and please share it with anyone you know who's also interested in Swift. Thanks for watching. I'll see you guys next time. Hey, did you join my free Facebook community yet? That's where I hang out along with a ton of other people learning iOS just like yourself. I also post early access to all of my videos inside that group before I put them on YouTube. You can also get help with any questions you're having. Visit the link below, click on the Join Group button, and I'll approve your request right away. Alright, so I'll see you in there. Talk soon.